Okay. So, yes, good morning, good evening, good afternoon, all of you. This is going to be an interesting adventure, giving an online tutorial to many people all over the place. So just to give a little bit of information, so we're going to use Zoom to give the tutorial. We'll be happy to get questions either using VFairs or chat here. One of us will be speaking and the others will look at the questions and so on. And we will ask everybody to mute at least while we speak, otherwise it's just going to be a little bit difficult in terms of presentation and so on. Okay, so I'm going to share the screen. And if I could check if everybody is okay. Do you see a beginning of the tutorial?
Yep.
Okay, so let's just start. So welcome everybody. It's great to have you joining us. We're going to spend about 4 hours together where Liangji and myself will talk about online user engagement, and the focus is going to be on metric and optimization. So to give a little bit the scope, the outline, we're going to first to introduce what we mean by online user engagement, also to give the scope of what this lecture tutorial is about. And we will have two big components of the tutorial, one around metrics, which is really to provide an understanding of what it is we're talking about when we talk about metrics, to have a feel about the usage of metrics. And the second part is going to be about optimization. How do we optimize? So what we want the metric, the way we want the metric to behave is behaving properly. And then we'll spend some time at the end with some remark and also a future direction. The aim is when we're done with the metric is to have a pause of 20 to 30 minutes. We will just experiment and see how it goes. So it's just to give you a bit of an idea if you need to plan things. But we'll just see how it goes. We have given this tutorial twice before in front of people. So this is the first time we're doing it online. And yeah, let's just see how it goes. Okay, so a little bit about who we are. So I will let my co-tutor introducing himself.
Hey everybody, good morning, good evening, good afternoon. So this is Liangji Hong. I'm currently at LinkedIn as a Director of Engineering AI, leading multiple machine learning teams, focusing on improving job search and recommendation. Previously, I was at an e-commerce marketplace company called Etsy. So you'll see a couple of the works that me and my coworkers have done in the past from Etsy. And I'm very glad to have this opportunity to meet you all through virtual channels. And yeah, let's have these 4 hours talking about metrics and optimization. Let's head over back to Monia.
Okay, thank you. So yes, I'm Monia. I'm based at Spotify in the London office. I lead a team of research scientists working on many aspects related to personalization. Before that, I was based in Yahoo and Yahoo Labs, also working around user engagement, but in the context of advertising, digital media, and search. I've always been actually quite fascinated by metrics and evaluation. Now at Spotify is really about how people enjoy audio. That's why personalization is important in that domain. This tutorial is based on previous version of a similar tutorial. The first one was in the web conference in 2013. It was very different to what it is there. I was looking at the whole spectrum of how to measure user engagement. While after that, the one at Wisdom and the one last year at Tap was around more the online user engagement. Based on last year tutorial, we made an few change, adding some references and a different perspective that we acquired since last year. Okay, so we're going to start now with the introduction and the scope. There are going to be three parts: some definition, then the scope, because it's important to understand what we're going to focus. And then we will present case studies. Those are studies where we have worked, and so we're going to use that as example to demonstrate some of the content that we're having here. So what is user engagement? Some definition. So the idea of user engagement is not new. There's been some work, for example, here in 2002, that tried to define this notion. And I'm just going to start with this definition because they already give an idea of something which is about the affective state, how people feel about an experience. And here, persistent and pervasive, which really related to the fact that it is something that just become a part of one, and so on. And it's not specific to a time. It's really towards like a feeling and something really related to becoming into something. It became second nature, and we can't escape. Then there is this work that actually has inspired myself and many others. I recommend to read it from both methodology perspective and really to get a deep understanding about how to even look at the concept of user engagement, from Heather O'Brien and Ellen Toms. And they came up with the definition as user engagement refer to the quality of the user experience associated with the desire to use a technology. And the interesting bit here is this notion of desire to use a technology, which is getting closer to the kind of contents and focus that we are having in this tutorial. And then based on this, we came up with our own definition, which we extend from this, maybe to narrow it a little bit towards more the online user engagement. So user engagement is a quality of the user experience that emphasize the positive action of interaction, in particular the fact of wanting to use a technology longer and often. And again, is to bring a little bit more focus by what we mean in terms of user engagement in the context of online, in the context of using technology longer and often. So user engagement have a number of characteristics. They're important to be aware of it because they allow really to think about metrics, to think about the importance, to often even come up with hypotheses about, for example, why maybe one particular functionality of a website is not working as well as it should be from a user engagement perspective. So there's 6 of them. A lot of them were actually defined in the previous work from Heather O'Brien and Ellen Toms, and then there's the other addition to it, adding maybe other components and so on. And I will go into each of them to give an idea. So the first one is focused attention. So engagement is when users are focused. If you like doing something, you're going to remain focused, and this is how engagement really happens. One way, for example, to think about it is if you ask a person how long did it take you to do that, and this is about the subjective perception of time used. So, for example, to complete a task, if the person say, "Well, that was quick, that was fast," even if actually it took longer, it's a sign of focused attention. More or less, it means that when you do something that really excites you, time passed very quick. Otherwise, it takes long. Usually time spent can be a good proxy of focus attention. And that's why it's often a measure that come back as a way to really understand user engagement. Aesthetic, so this is about the look and feel of the experience, the UI, the functionality, and so on. Visual appeal, interface, and so on. More or less an interface or presentation and so on are not good. This is not going to help user engagement. So it's really about the perceived usability, and it's linked to design principles, symmetry, balance, and saliency. So this is really, to some extent, the look and feel. Often, what I tend to say to people is, if the aesthetic is not there, even studying user engagement is going to be hard, or measuring user engagement is going to be hard, because it's just not going to work, because for example, the site is not going to be usable and so on. So this is often like, if the aesthetic is not good, maybe revise aesthetic and then try to understand user engagement and how to measure. Novelty. People don't like to be bored. They like novel things, they like surprise, they like something that is not familiar, unexpected, updates, innovation. This is often related to serendipity, discovery, and freshness. So for example, in the context of news reading, people expect new content, fresh content. In the context maybe of watching some film, they expect, oh, this is something new, I didn't know about it. So this notion of novelty is very important. A level of novelty depends on the application. You do not want every time you log in into your email account that you have a novel interface and so on. It really has to do with user curiosity, and they really push user to want to do something, to want to repeat the engagement, because they know they're going to get something new every time they engage with a particular product, website, and mobile app. The next one is reputation, trust, and expectation. So trust is a necessary condition for user engagement. You have a relationship with the product, you know what you expect with the product, and it's more than the technological component that it is working. And something, for example, in some aspect of trust is going a little bit to habit, you know, what you expect when you go back to that product. For example, Wikipedia, the level of trust or implicit contract between the user and that product would be different, for example, with respect to news and end user. So this is an important aspect of user engagement. Positive affect, so this is the feel, this is emotion, this is cool, I liked it, I want to redo it, and so on. It's this notion, ooh, that was a good experience, it made me happy. I'm saying this way because horror films can make people happy, but it's not necessarily like a happy experience in the sense that they're smiling. Positive effect also relate to discovery and participation, a satisfactory experience, and how people feel and relate to it. Endurability is if you've done something that you have enjoyed, useful, it was engaging, you want to repeat them. So this is about the repetition of use, recommendation, interactivity, and utility. And this is what a lot of the work around measuring user engagement relate to. Good experience, I want to repeat it. So this is really at the session level. And to some extent, it relates to the in-moment experience. My session was engaging, satisfactory, to going to future experience and so on. Richness and control. Richness captures the growth of potential of an activity. Again, this is about Users don't want to get bored. If something is not challenging enough, they might just decide to use something else and to go elsewhere. If it's too challenging, this is where control come into account, they give up. This is particularly important in the context of games. It has to be rich, it has to be challenging for users to go up the various level, but there is always this level to, if it's too difficult and so on, to give up. And usually there's quite a lot of work to understand what is the right level of challenge, but allowing a challenge that does not push a user just to give up. And there's been some stories about level in some games where, okay, like 50 or 60% people give up. That is not good in terms of overall retention and growth potential. And finally, what the app, the site, the feature is about, the motivation, interest, incentive, and benefit. Why would I use this? So those are the various levels. They kind of relate a little bit, although they have a different perspective. And sometimes I'll get back to them, or sometimes they are implicit in even how we talk about user engagement, and some metrics, often what I refer to proxy of some of those characteristics. So what I want to focus, and what we will be focusing, is this notion of the quality of the user experience. We relate this to endurability. People remember a satisfactory experience and want to repeat them. And what this lecture is about is really to look into this, and trying to look at metrics, because we need metric to quantify the quality of the user experience with respect to endurability. And this is giving already a little bit of the scope. Good experience, I want to repeat it. And we will talk quite a lot about what this means, how to optimize, and so on. So why is it important to engage users? There's a lot of competition. Users have a very much increasingly enhanced expectation about what their interaction with the technology is. Not just now what I call utilitarian factor, is doing the job, is usable, and so on. Is more than that. It's about how the experience is. Hedonic, experiential factors of interaction, fun, fulfillment. And that's why user engagement is becoming, or has, but it's increasingly becoming important. It's not just about getting the job done, it's about how the experience is in getting the job done. Competition means there's always, okay, we better ensure that what we're offering to a user is engaging. And again, how do we know that it is engaging, and how do we know we are measuring it properly? So taking a bit of thinking, so the engagement life cycle, there are 4 parts. The first one is point of engagement. So this is the beginning, the user coming, how engagement starts. So aesthetic is an important part, novelty is important, of course, user interest and context. The second one is period of engagement. So this is the ability to maintain user attention and interest. This is really how the session is. How is the experience? This is how the endurability come into account. And this is it's going to be the focus of this tutorial. Disengagement is loss of interest, leads to user becoming passive and even stopping actually using the product. And there's a lot of work looking into identifying users that are likely to churn and try to do something about it. There's also re-engagement. So users have gone, been passive and so on, and there's a way to try to bring them back. Novelty, convenience, remembering past positive experience. And so there is still this in users, but how to trigger for them to come back, for example, using a campaign strategy. The focus really is going to be on period of engagement in this tutorial. But to give a little bit more still the picture. So the point of engagement is how user arrive. There's often an acquisition cost. So this is what is referred as acquisition. We have new users. Now, when the user become more active, this is activation. So this is active users. So they are users of the product. And we also have sometimes they don't become active. So there is a disengagement. So those are dormant users. So they're still on the product, but they don't use it. And usually this lead to churn. They just get out. They just, for example, cancel subscription and so on. So this is kind of, the slides just put everything like together. So an active user can become a dormant user can be re-engaged and then become an active user. Re-engagements can be done notification, email, offer, advertising, and so on. This is important to remember because this is the whole engagement life cycle. Engagement is not just about my session goods. It's the session satisfaction for the user to come back. It's also about how do you go from new user to active user? How do you go from dormant user to active user? How to avoid being an active user and then becoming a dormant user? But again, the focus here will be of this notion on endurability, which is the period of engagements that relate to user behavior with the product during a session and across a session. Again, it's going back to this notion of pervasive, which is not just about this was a good session, it's just how the session was and how that's going to impact future sessions of a user. So now we're going to look a bit briefly about some consideration in measuring user engagement. So it can be short-term, long-term, short-term, an A/B test. After 3 days, you stop. Long-term, longitudinal studies. It can be laboratory, you get some user to come, or in the wild. For example, you deploy something, you test something with maybe 1 million of users. It can be subjective, you ask user, you have questionnaires, or it can be objective. You measure things about them. For example, how often they spend on the site. It can be qualitative. So again, the subjective is often related to qualitative. Qualitative, which is really come from understanding a user at their own level, the quality of the experience, and which is different to quantitative, which is how often a user click and so on. Large scale and small scale. Usually, for example, laboratories study are small scale because you need user to come, maybe 20 users to come, participant to come, while large scale, this is where the more kind of online user engagement. There are kind of 3 overall methods to measure user engagement. We will focus on the last one related to online analytics, but it's important to be aware there's other methods, self-reported methods. This is going back to subjective, so via questionnaire, interview, reports, and so on. Physiological measurements. So this is what we try to measure things, not by what the user is saying, but what they're doing. So for example, task-based method is we give a user a task, we see how that user is performing, we have questionnaire associated with that task, and for this we can derive some sort of understanding of the engagement. There's just all this area of physiological approach, for example, eye tracking, muscle spasm, trying to understand brain wave, but also mouse movement that is a bit more large scale. And actually, I will talk a little bit about mouse movement as a signal that often help in understanding user engagement. So the physiological measurements are more objective because it comes by observing users or participants, and less about what they're saying about their experience. And then the online analytics, which is where the data science and the machine learning, this is very quantitative, large scale, and so on. Those work they're not totally separate. Usually understanding user engagement or user experience by self-reported method help deciding what would be a good metric later on and so on. So it should not just be about online analytics. Some of the others can help bring in quite a lot of additional knowledge, for example, to do online analytic better. And again, there will be some examples. So the scope of this tutorial, because we can't cover everything, is going to focus on online analytics, online user engagement. We're going to assume that the applications are properly designed. By this, I mean in terms of usability and content. So a horrible website that nobody can use, we're not going to look into this. And content that is questionable, like fake news, we're not going to look into this. The tutorial is based on published work and also our own experience, because both tutors have been working in that domain. And we're going to focus on applications that users choose to engage with, widely used by anybody on a large scale and on mostly regular basis. So for example, if there's a tool at work that everybody has to use and nobody really likes it, we're not going to cover this. And finally, this is not an exhaustive account of work in this unrelated area. And we welcome also if people have been working and do this or other work in this, feel free to share with us. Okay. Longji, are we good? No questions so far?
No questions so far. Yep.
Okay. So next, we're going to describe together some case studies because we're going to go back to them as example. For example, when we talk about metrics, how we optimize, and so on. So we're going to talk about e-commerce, search, news, streaming, and advertising. And I'm going to give it to Yongji for e-commerce.
Yeah, thank you, Monia. So for e-commerce, the primary goal for e-commerce is to engage users and such that the users want to buy products from e-commerce site, right? So this seems very obvious. But in reality, it's not that easy, right? So if you look at just some of those screenshots here, sorry, Monia, the previous slide. Monia, could you go? Yeah, could you go back? One slide. All right. Yeah. So if you look at the sum of screen here, you are going to see a lot of things going on the screen, right? So you see search bar, you see different modules, you see marketing campaigns, many advertisement, and many other things. So it's very, very complex in terms of for e-commerce site to attract the user to purchase something. So purchase is a decision that being made by consumers via interacting with the ecosystem of the website. So we are going to talk about what does it mean, how to analyze, how to understand it later in the tutorial. Next slide, Monia. All right, so, but one step even beyond that, right? So if we say e-commerce is the mimic of shopping experience online, right? So mimicking offline experience. And if you think about your offline shopping experience, like, you know, walking in the shopping mall, you are not only buying things that you intended to buy, but you also get inspired by things you wouldn't buy at the first place. So this is an even more challenging task for the e-commerce side, where we would love to inspire users and eventually, right, so they get a very, very good experience of purchasing things that they wouldn't buy at the first place, or they discover new things, right? So this is even beyond purchasing behavior, but they're focusing on the inspiration. We're not going to talk about the inspiration here in this tutorial, but just throw out the idea there, right? So what's the ultimate goal for some of the e-commerce side? Let me hand over back to Moni.
Okay, thank you. We will have a number of examples related to search. So search is a well-studied problem. It's not a solved problem, but there's been a lot of work related to search, and in particular, understand what is search satisfaction at the session level. It's not exactly user engagement, but there's a lot of, for example, proxy of search satisfaction that do relate to user engagement metric. A little bit more in terms of search. So how do we evaluate search? We do that looking at 5 different things. Coverage is to have a good coverage of everything that in that domain is searchable. So that's very important things. And here I'm not talking about search engine just in the context of the web search engine, but also other type of search engine that are, for example, more local and enterprise and so on. There's the speed. There's the query language. We're aware of the 2-3 words, but in the domain of, for example, law or biomedicals, it's a different type of behavior, and of course the user interface. A lot of the work around search and evaluation has been in terms of relevance. Are we retrieving the right document, the document that are relevant to the user? So going back to user satisfaction, so user find what they want and return to the search engine for the next information need. So this is where the notion of user satisfaction lead to user engagement. They had a good session, they return, and this is really when we start talking about the user engagement. And also in addition, where user engagement and user satisfaction in search are a little bit different, they're not the same, is because if you're carrying out a search task, it's not the end task, it's something that is bigger and so on. So it's just important to understand, yes, we can learn a lot from search and user satisfaction in search, and it's helping us understand the user engagement in search and elsewhere, but it's not equal to user engagement. Back to you.
Right. So after search, so here is about news portals, right? So you can see a bunch of recent screenshots, not too many exciting news around the world, but the purpose of the news portals, right? If you think about it, the first degree is to attract users to read and to click on things to get information. So the first kind of the metrics we want to optimize and monitor are around the click-through rate and the things that immediately attract users to engage. And that's pretty much a lot of news portals are doing. So we're going to share some of these things from you know, the work we did at Yahoo Labs and so on and so forth. Next slide. But again, right, so if we really think through and how we can attract users and retain users further, is actually going beyond the immediate clicks, right? So it is going beyond to really measure how users can spend time on different pages and how they are satisfied with the results, right? So then there's a notion of dwell time. So we're going to talk about how to measure dwell time, how to utilize dwell time as a proxy to quantify how users would like to return the site and so on and so forth. And the nutshell here is that focusing on different areas, like instead of optimizing clicks, we're optimizing dwell time, we will end up with recommending very different set of articles to users. So that indeed tell us that there's a very true effect of optimizing different metrics, and long-term engagement is important. Back to you, Monia.
The other case study is streaming. Well, the reason is one of our case study because I work at Spotify. There's actually a number of work that has been looking at streaming, published also Netflix and other in the streaming industry. So here there's the audio streaming, but also video streaming. And this is, for example, access to music application, desktop, mobile, tablet, various kind of experience, various features. We have playlists, we have artists, we have tracks, and so on. And it's really interesting to know what is user engagement, what is success into, for example, one component or one part of the app compared to others. And I will have a number of examples that go back to this because this is something we also are very much researching currently. Then the next one is advertising. As part of Yahoo, I worked in the advertising science team. So advertising, you have advertiser, you want to do that from a brand perspective, where advertising is about just showing some ads, or you want to do that with aim of a direct response, showing ads where you want user to click. This has an impact on the cost models, cost per impression or cost per click. And I will also present some of the work that we have done in the context of advertising quality. Advertising is everywhere. It's as part of search, native advertising, which I have worked, but also display ad and video ad. Just a little bit of native advertising, because there's quite some example here. So native advertising is something like this, where you have a stream, for example, a news stream, and you're going to have an ad within that stream. It is going to be shown as an ad, but it's going to try maybe to keep the same look and feel and so on. And this is a big industry. And the idea here really is, the reason for this is much more engaging from a visual perspective. It has also higher user attention, higher brand lift, and also social sharing. And there's been quite some interesting work to see, because it's a bit more kind of a part of the experience. So it's a little bit different in terms of how to measure engagement. Or how some metric related to engagement can be used to study particular aspects of the native advertising experience. Okay, so those were the case studies. We will go back to them throughout the lecture. So now we're going to start getting into metrics. The things is moving too quick. Okay, so by metrics, I mean online metrics. So we're going to start with terminology, context, and consideration. And there's going to be a big focus on what we call intra-session metrics. So the metrics really that assess the quality of the session. And then inter-session metrics. So this is about really, since this engagement is not just within a session, it's a cross-session. So it's important also to look at those metrics, and importantly, how inter-session helps in inter-session. And then we will discuss all the metrics, because it's not just about a session metric, and then we'll have a break. Let's start. So measure, metric, and key performance indicator. So what is a metric? It's something here that is in the middle. First, there are measurements. So measurement is the process of obtaining one or more quantitative values that can reasonably be attributed to a quantity. Number of clicks is a measure. Time spent is a measure. A measure is a number that is derived from taking a measurement. In contrast, a metric is a calculation, click-through rate. I want to make it clear that a measure can be used as a metric, but not all metrics are measure. So you can use a measure as a metric, but the other way is not correct. And then we have what is called KPI, key performance indicator. So those are quantifiable measures demonstrating how effective key business objectives are being achieved. For example, in e-commerce or in advertising conversion rate. Again, a KPI is a metric, but not all metrics are KPI. In the work that's what we're going to be describing in this lecture is really around metrics, but it's just important to see how they relate to the other two part, measurements and KPI. There is a relationship, of course, with them. So we have what is called business metrics. So this go back to the KPI. We have behavioral metric, which are the online metric and analytic, and we have the optimization metrics. And what I want to say about those is the behavioral metric, usually this is often when we try to understand something about user behavior in that way via analytic, we do that via manual optimization through, for example, A/B tests. When there's an A/B test, it doesn't really necessarily relate to the KPI. KPI could be number of active users at a certain time, but there should be some relationship. And then we have the optimization metrics that can be equal or a little bit different also to the behavioral metric. Those are the metrics that are used to train a machine learning algorithm. And this is where the auto optimization come into account. And we'll have a whole part of the tutorial looking into this. So what I'm going to talk next is really around behavioral metrics, taking into account that behavioral metrics are related to some extent to optimization metric. And at the end, everything we're trying to do is to ensure that the KPI, the key metrics, are kind of going into the right direction. So why do we need several metrics? Why don't we have click-through rate is used everywhere and so on? Because the way users engage with an application really depend on the type of application. So for example, in games, users spend a long time per visit because they're just playing and so on. Social media, this is more coming frequently to the sites and staying to some extent, maybe medium amount of time, it depends. A service, user visit the site when needed. So there's not a lot of interaction, but it needs to be there and need to work when the user is needing to do something. Search, user come frequently, but do not stay long. Search satisfaction is when the user come, has a query, submit the query, get the result, and that's it, and so on. So this is why this notion, maybe the time span is an indication that the search has not been successful, but frequency coming back is an indication of this is a good search system. Niche, so this is some sort of website where it's really about specific, very niche content. So maybe this is, for example, some of the magazines, they update their content every week, once a week and so on. So again, it's a different type of expectation in terms of metric. For example, just reading, so time spent, somebody coming once a week and spending some time, that's a good indication that that site is engaging. And news, user come periodically, morning and evening, again, there's a lot of click, there's some time spent and so on. So again, it's not just one metric, it really depends on what is the intent of the site application. And even within the application, we still need several metrics. And this is in the context of Spotify, audio streaming, this is in the context of music. User go into some of the playlists and there's different intent with the playlist. So depending if you're going to want to relax or try maybe to create some sort of playlist for a party, the interaction is going to be very different. The metrics are going to be very different. And I will say a little bit more afterwards. Depending, for example, Spotify being an audio company, we have music, we have also podcast. We have content that is maybe fresher than others, for example, charts. This also causes different type of behavior, which means different type of metrics should be used. Podcasts are much longer than, for example, music. Search is again very different. Users have a particular intent, they want something. This is different that if they go, for example, on the homepage of Spotify and trying to see, oh, what is there? What is it I'm going to listen now? Again, home in the context of music, but also elsewhere, it has this notion of being the hub where you can view it as some sort of star-style engagement pattern. People go, find something, and come back. And this is, for example, important in news portal. And even when you go into some sub-hub, you have sub-hub, which often they will have their own engagement pattern. So even within the same context, we need several metrics. And again, so let's go even further. So let's just look at metrics within playlist. So how do people listen to music? So we have the very leaning back experience, sleeping playlist, chill at home, and so on. Success here mean engaging experience mean that the user start the playlist and just didn't stop it and just listen without interruption. And then you have the opposite, leaning in. So this is where maybe you're looking for something new, you're looking at what is trending, you are into discovery modes. The playlist metric here is downstream, what action has happened from the click, how many artists you have discovered, how many percentage, number of track or percentage of track sample, even if you haven't listened to it, because it's kind of testing and so on. And you got things in the middle, leaning in, active, okay, not creating something new, I'm listening, and if I don't like it, I'm just going to skip it, and so on. A bit more occupied background music and so on. So again, even within a playlist, we need different metrics. Now let's go back. So where are we? So
hey, Monia,
yeah.
there's
Yes.
a live question saying the leading is asking, where does streaming fit in? So I guess or she or him.
With a streaming.
Right. I guess that's a question.
Can you repeat the question? I don't understand the question.
Oh, that was an old question. Oh, never mind. Probably.
Okay, I'm happy to answer the question, but I didn't understand the question.
Maybe later. Yeah.
Okay, so going back, so those were trying to understand why we need several metrics. Applications are different. Within an application, we have also difference and so on. So this is going back to the quality of the user experience and endurability. So what's now the rest is going to really to focus on what I call active user. So we have users that are active. Activity could be very active to semi-active and so on, but they are using the application. And from there, we're going to start looking at what kind of metrics should we look into to try to understand the quality of the user experience, knowing that it's not one metric for, you need more than one metric. It's not one metric is enough for all possible user experience. So the way to look at this is by thinking at 3 levels of engagement related to endurability, the quality of the user experience. The first one is involvement. The user is there. It's a page view. There's a page. Dwell time, spending time on the site, on the page, play time, for example, playing a video and revisit rate, and so on. Interaction is where there's an action of the user. The user is doing something, a click-through rate, share, like, conversion, save, a click, a skip rate. And then there's contribution, where the user is actually adding something. There's an input from the user, either via posting something, commenting, creating something, update, and so on. Uploads, and for example, creating a playlist. So what involvement mean in application A may be interaction in application B. So it's not like, oh, this metric is involvement. It depends on the application. One particular metric that it's the basic of everything, is a special type of action, is a click. Before involvement happen, you need to arrive at that place. You need to arrive at that news item and so on. So that's why it's a special action and is often a precursor of other levels of engagement. And we will talk a number of times, we already started, what is the value of a click? It's a downstream engagement, what happened after the click? So when we talk about involvement, it means after the click, when the user is there. So it's important to be aware of this. Degree of engagement in terms of intention increase from involvement, interaction, and contribution. If I'm just there's maybe not a strong intent to some extent. When I do something, of course, there's something. So it means like a stronger connection already, and the contribution that's even stronger. And a lot of the work I have done and so on is when there's contribution happening. This is very much often associated with higher retention. For example, people writing comments and in the news. For example, you have news article and it's possible to make comments. The number of people writing comments is less than just, for example, the one liking a comment or the one just reading a comment. But those are the ones that are super active and have a higher retention and so on. And that's just is also applicable in other domains. So now we go from those 3 levels: involvement, interaction, and contribution. So this is really what is happening during the session, during the experience. And now we're going to go a little bit more, what do we mean by session? So, and again, this is a little bit of kind of terminology. So we have visit. So visit is when you are within the app, within the site, and you have consecutive visits, and this is a session. Usually you say that this is the end of a session to the next session. That tend to be like a 30-minute is used as a threshold, although there's more research, for example, in other type of application and so on. So the dwell time is often the time spent on a site, a page during a visit. So on a site or a page, and the session length is the amount of time users spend on site within the session. And session frequency show how often users are coming back. And this is a notion of loyalty. So again, this is a session, the number of visits within that session, understanding that session, and then, oh, there's a next session, and then there's a next session. And this is where we try to start to get a good understanding about user engagement. Now, adding to this, so we have the end of a session. So when you try to understand the quality of the session, this is where we have intra-session metrics, page level of less, visits, session level, and so on. And we'll talk a lot about this. Those tend to be the metric that really, for example, when we find that others, they relate to the metrics that we want to optimize with machine learning, for example. Then what comes next? So that's the session, that the next session is about returning soon, remain engaged later, and so on. And this is inter-session metrics. Those are very important to be aware of because at the end, you can do whatever you want with the intra-session metric. If you lose the users, if you don't account what happened next, well, there's no point, and so on. So there's a lot of work is what intra-session metrics are good proxy of users staying longer, and so on. And we'll discuss some of it also later. And then we have what is called long-term value, LTV metric, which is really the value associated with the user being on the application system and so on. And I will end my part saying a little bit more about this. So this is a busy slide, but so let me try to kind of explain how everything fits. So we have intra-session on one side. So this is within the session, and it relates to endurability, the quality of the experience. And then we have on the other side, inter-session, which is trying to understand the quality of the user, of the experience across session. So let me just focus at the moment with intra-session. As introduced earlier, we have 3 levels of engagement: involvement, interaction, and contribution. And what we listed here is example of what is a metric related to involvement. For example, dwell time, session duration, revisit rate. metric that could be part of interaction level, type of engagement, click-through rate, number of share, likes and save, conversion rate, and contribution, number of replies, number of blog posts, number of uploads, number of playlists. There's also granularity aspect. We want to understand everything with respect to the whole session, but is also maybe only part of the site is what we're trying to optimize. Also, we want to optimize the viewport, what the user is seeing, maybe the whole page, or maybe just the visit. Now going back onto the other side, the intersession. So this slowly, before I used to always refer to it as loyalty, but I decided to put something in the middle, which is about habit. So if a user is engaged with the site, they develop some sort of habit with it. That means that they come back very soon because they have developed a relationship, which I prefer to really refer it to as habits or returning soon. And this is often one way to look at it is time between session and absence time. And then there's the bigger one, the intersession, which is across many sessions, and this is a loyalty. So it's just about how active users are over time. This is really related to retention, number of active days, number of sessions, total users times, and so on. And this intersession thing, looking at habit and loyalty, of course, if you develop a habit, then it has a relationship to your loyalty. Has, for example, a number of us look at the problem of intersession differently than just thinking about it into loyalty. It's maybe subtle, but if you think a little bit more, going back about the expectation, I'm going back to the system because I have developed some habits, I have a trust, and I'm hoping that the system is going to fulfill that trust. And this notion of habit. And by having this habit, then loyalty comes. So that is really gives you an idea of metrics and so on. As I said earlier, maybe dwell time, it's an involvement somewhere, maybe it's a contribution elsewhere and so on. So it does not mean, okay, that is involvement, that's its interaction. It depends on the application. And again, remember, click is a little bit different because even session duration, you have to arrive somewhere, for example. And for this, it has to be done via click.
Hey, Monia, there's a question.
Go ahead.
So Virish is asking, are there some techniques to determine the appropriate session length for an application? Also, are intersession metrics sensitive to the length of the session?
There's been some work done in the context of search. And often, for example, what work we have done is we just use 30 minutes, we use 50 minutes, and we often see there's no difference. So there is not particular technique. It's usually by looking often at distributions and so on, and just to find one and so on. What is more difficult and more promising is to look at the end of a task, which may involve several sessions, and that is the challenge, and so on. In terms of intersession, I'm going to talk a little bit more about this coming. So hopefully I will be able to reply to this and so on. Is this good?
All right, I think that's good.
Okay.
Somebody mentioned 30 minutes for web, 15 minutes for mobile. Sounds like
that is, yeah, I'm not 100% sure. But it's a good one. But it also depends on the habit to some extent. And I will talk about something which is online multitasking, which also change a little bit. To some extent, you have to think. But often at the end, what people tend to do is when they're studying things, they take various thresholds and look at results. And when there's no big differences, they just choose one of them, but usually through distribution. Okay, so continuing now with the intra-session metrics and inter-session metrics. So intra-session metric, it's module, viewport, page, visit, and session. It depends really what it is we're trying to measure. Remember, for example, of a news page, you have various components, various modules, and which is different to try to optimize for the whole news page. And in fact, there's going to be some discussion about this later. So the optimization is mostly with this metric with increasing complexity from module to session. And then the intersession metrics, to some extent, it's something related to the next session, next day, next week, next month. They often come from product business decisions and so on. They are related to loyalty, they are related to popularity, they are related to retention. And so on, and how they relate to the intra-session metric is will be discussed very soon.
Another live question.
Okay.
So Dimitri is asking, I'm not sure if this topic is to be covered later, but what is a rule of thumb to link this behavior metrics with LTV, long-term behavior? Or do you assume LTV is represented by these metrics themselves?
LTV is a different thing, and I have one slide at the end. LTV is really the lifetime of the user, the value of the user, and how it is. So, for example, you may decide that click-through rate is part of this LTV, but it's not the only part. It's also acquisition cost. What is the cost to acquire that user, and how much click that user has done. So that is a relation. So again, those metrics can be used as part of the LTV, but it's not the only part.
All right.
Okay. Okay. So now what I'm going to do is to go through intra-session metrics, definition, and the challenge. Why it is difficult, and why people need to think about it. Increasing a metrics is good in general, but it's important to understand what does it mean. Is it really good, and so on. So I will start with click-through rate. So this is CTR is a very, very common metric, mostly used. So is ratio of user who click on a specific link to the number of total user who view a page, email, advertisement, or something else. If you go into more the streaming industry, is you've seen a video, you've seen a playlist, the ratio of how many were streamed compared to the total time for example, the video or the playlist was shown. And so on. When there's a time aspect to it, this other thing related to it, was it's fully streamed, that's an additional thing. So this is going back again to this downstream engagement. But here is really the click. I'm into it. I just click. I'm starting to look into this. And when you talk about click or click-through rate, there are a number of components that are important to think about: abandonment rate, clickbait, site design, and also accidental click. And I will just give examples for each. So no click. So no click does not mean it's not a successful. It does not mean that it's not successful. So for example, in the context of search, there's a lot of really rich content that is returned. So for example, I only want to know what are the dates of KDD 2020 and where it is, well, where it should be. And I click, so I submit KDD 2020, and this is the result I have. I don't need to go further because I have the information I'm looking into. So that's, again, this notion, no click does not mean it didn't work, at least in that context. And there's a lot of such cases in the context of search. Going further, so this was work that was done in 2011 in the context of Microsoft research. So this is looking at mouse movement on the interface. So it was a laboratory study, and where there was search queries, users were asked to look for results and look at what is relevant and so on. And this is like a table that summarizes interesting things. So click-through rate is the percentage of click when the URL shown. Hover rate is with the mouse, you go over a URL, and this is per query. And click hover is the median time user hovers over your URL but did not click. And max hover time is the maximum time user hover over a result in terms of the whole search engine. So it's interesting if you separate the session where there's a click and the session where there's no click. So when there is a click-through rate and hover rate are highly correlated with human relevance judgment, meaning this document was relevant. And when you combine everything, you get the correlation increase. When there is no click, actually, the hover rate is a good indication of some level of relevance and so on. So there is this notion, there's maybe no click, but there's some sort of the user paused and look at the result. Again, so this is this notion of mouse movement, hovering, that gives additional information in terms of the case when there's no click. Looking into this abandonment, which is a measure that is used in search, but also elsewhere. Abandonment is when there is no click in here in search on the search result page. So user is dissatisfied, so bad abandonment, and user find result on the search result page, good abandonment, and which I already give an example. So again, continuing from this work, it says 158 queries, 21% good abandonment, 79% bad abandonment, and they manually examine how the cursor move. And for example, characteristic, the trail length. So the total distance pixel traversed by the cursor was shorter for good abandonment, meaning the result was there. The user just went, ah, yes. Movement time is the total time the cursor moved on the search engine result page, the longer when answers in snippets. So actually the user is actually reading. Then you have the cursor speed, is how fast the cursor is moving. So it's slower when answer is snippet. So this is like, again, this notion of focus attention. The information the user is looking for is there. So there's a focus. So focus attention is you move slowly, and also the movement time is also longer. So again, going back to those characteristics of user engagement, that's quite a good indication of focus attention. Again, this is a notion, abandonment rate is not always bad. The quality of a click on mobile apps. So this is in the context of advertising. So we worked on what is called ad quality, and ad quality is user going on, so they click and they end up on the mobile page. And if the ad is relevant, the expectation is the user stay on that mobile page and just do whatever they need to do, for example, to buy the product and so on. So here, this is a plot that shows the same ads, but on two different apps, for example, mail or news. So the same ads, but displayed in other on different space. And we look at the bounce rates, and it looks strange. The same ads. We were very careful that it has nothing to do with the user population, the segmentation, and so on. And so you see those kind of, in one case you have like 2 peaks, and in another case you have 1. And this was really actually something related to by design. And in this this peaks there was mostly due with accidental click, which is something that happened in the context of mobile. So accidental clicks do not reflect the post-click experience, and not all clicks are equal. So again, this notion of click, again, going back to what happened next is an important part that is beyond click-through rate. In the context of music, click-through rate, so ratio of user who click on a specific item to the number of total user who view that item. Of course, there's a discussion, what is an item? Is it the track? Is it the artist page? Is it the album or the playlist? And again, we go back to this notion of the value of a click, the downstream engagement. What happened after that click? And this is something we're looking into at Spotify, because it's about this notion, again, building relationship. It's about this trust, this contract with the user. And so why we're focusing on downstream engagement, so you have the click-through rate, you need this click, but then you look at what's next. So what the user does from a particular click at place X, for example, depending, is it artist, is it just a track? And we look at various downstream behavior, and then it gives additional information about the value of the click. And we have a little bit of this explained in a web conference last year. Okay, so that is click-through rate. And what I tried there is really to often, there's the click, it's pretty conventional, it's used everywhere. And giving you a little flavor is what happened after the click. And those, for example, dwell time is something that is often looked into in various applications. So what is dwell time? Dwell time is a continuous time spent on a site or web, in the context of mobile page, is often a good indication proxy of interest. Again, this focus time, and is being demonstrated in various work. Similar in for example, in video streaming and so on, it's about how long the user is, for example, streaming something. So this graph there show that dwell time varies a lot depending on the type of website, which mean, again, you should not just assume, oh, that's a good dwell time. It's very, very site specific, and also not just that, is also very user specific. With dwell time, as I say, is an involvement metric. We're not clear what the user is actually looking. And so that's why the click, understanding the click, and then understanding the dwell time is important. Dwell time also vary by site type, as I said. So leisure sites tend to have longer dwell time than news, which makes sense. If you're watching, if you just like playing games and all those kind of things. But also at the same time, dwell time has a relatively large variance even for the same site. And this is where, if you understand what is a good average on the site, and then you see variation, this is where maybe you try to understand where user interest is. And this is, for example, is important in the context. It has been shown to be a good characteristic of understanding user interest in the context of news. And we will talk about this later. In the context of search, again, going back to eye tracking, or no, here it was in context of cursor heat map. So in search, you click on the results, and then you look at the results, the documents, and usually the longer you stay, the stronger indication that the content was relevant. Here, it's you have a dwell time of 30 seconds, which would be an indication not relevant, but in some cases relevant, because this was a laboratory study, and the other is not. And what you can see, again, this is notion of focus attention. It was the information the user was looking for was at the beginning, while in the second one, the B case, when it's non-relevant, is just like skimming, trying to find this information. So again, it's single time, different behavior. And that's why there's a lot of work trying to understand at the cursor position, maybe how the viewport is moving, and so on. And this is the other way around, where we have longer dwell time, 70 seconds, meaning likely relevant, but in some cases it was not relevant, and so on. So again, never take a metric. Okay, we got it up, good, it's working. It's more than that.
Monia, another
Yes.
live question. So
Okay.
Christian is asking, in relation to Spotify, is the goal to have the user engage in listening to music, or to interact with the interface?
Engage in what? I didn't hear the last bit.
So engaging in listening to music or interacting with the interface. So which one, or both, I guess? It's
both. You have, if your intent is to create a playlist, clicks are good. If your intent is to sleep, is to click and play and not touch it. That's why it's very playlist specific and so on.
Got it. Thank you.
Okay. Continuing with dwell time has been shown to be a good proxy of user interest in the context of news. It has been actually has shown to increase click-through rate because it have reduced what we call clickbait. So contents that is really for that to get a click, but user bounce back. I'm not saying too much about this because Yongjin will talk about this later, because this is the interesting part, is like, how do you optimize this? So it was identified as a good metric to look into, and then the next step is how to make it work. Again, very briefly, in the context of music, we exactly see that. So consumption time of dwell time on average across all possible Spotify playlists is around 23 minutes. Sleep playlist is 43 minutes. If you take into account the type of playlist and have, for example, the metrics that is optimized for the type of playlist, you increase your prediction and by 22% and so on, which is makes sense, because you know, okay, this is a sleeping playlist. Success is when you're above the 40 minutes. While if it's just a click, you don't take into account of the type of content. And we have also some work that was presented last year. In the context of ad quality, ad landing page quality, so it is also used as a proxy of ad quality. You click on an ad, you go, you spend time, it means the quality is good. And actually, we demonstrated that long click, so the user didn't come directly back, were a strong indicator that of user clicking on an ad again compared to short clicks, which make us very feeling very confident that it was a good proxy of ad quality. Okay, how am I doing for time? Okay. Organized metric. So this hopefully will answer one question. So this is in the context of search. So when users search in music, they have a need, they type it or talk, can use voice, they look at the result and then they decide. And this is often has been categorized into effort to find the content and success. To decide, okay, great, I'm just going to do something about it. Oops. I'm getting this wrong. Yeah, sorry. And this is what we mean by organized metric. So success metric here is you stream, or going back to the question now is, oh, this is a track, this is interesting. I'm going to add it to a playlist. I'm going to save it into a collection. I'm going to follow that artist, and so on. And actually, what we did, we looked at those stream, the listen, and the organize, put them together at success metrics. And when we ran A/B tests, the A/B tests, they are more sensitive than just looking at the click-through rate. So again, this is organizing is getting a little bit more, it's a stronger action than, for example, just streaming. It's going even up to contribution, one of the level metric I discussed earlier. Revisit rate. So this is important to look into in the context of hub. A lot of the application have a hub. This is where you start. So this is a number of return to the site, or maybe with respect to that page within a session or successive session. This is where the notion of task come into account. As I said, commonly cited at the home page or on content of regular interest to user. News aggregator are one of those, and so on. This is where recommender system come into account, because you just come back and you expect, okay, where do I go next? Revisit rates is a good way to look at this notion of engagement. We look at revisit rate. This is in the context of 50 sites from our time at Yahoo. For example, goal-oriented sites have lower revisit rates in a given time because you have a goal, you do it, and that's it, compared to more kind of hub things. Again, the revisit rate is something to do what is the notion of a session and what is the notion of a task. And I want to say a little bit more work we have done into that. So this is a study, offline study, 2.5 million users, a lot of page view, 1 month example, and we categorize web site according to categories, for example, search, blogging, front page, and so on. We look at short session, and in a session we had maybe around 3 distant sites being visited with a revisit rate of 10%, and long session 9.62 distinct sites being visited with a revisit rate of 20%. So what this means is within a session, user will just hop between sites, and this is important to look into. This is again going back to this notion of task. User is booking a holiday, they will look at price of flight, they will look at destination, and so on. So it's going beyond just the one site. And again, this is where this notion of time between each revisit is important. So for example, in the data we have, 50% of sites are revisited after less than 1 minute. So that's why the 1 minute is definitely not a good sign of that's it, that's the end of the session. The user is still likely within a task. And this is this notion of multitasking that is important. And there's also work about multitask optimization, trying to do several things. And this various work are looking into this. 3 more, okay. I'm just going to, yeah, okay, we have page view. So page view is what is called click depth. You just click and there's the page and so on. It's often used in many areas. It's the average number of contiguous page viewed during a visit. There's a user journey across the application. There's a notion of when it's like page view counted and so on, especially in context of news streams. Yeah, so this is related to click, and it has some instrumentation aspects in context of streaming that is very much related to click. Conversion rate, this is very important in the context of e-commerce, making a purchase, but it's not just e-commerce, it's also subscribing, booking a room, in the context of, for example, Spotify going from free to premium. Online advertising is using also conversion as a cost model to charge advertiser, but that's something also to be very aware. It's not all sessions are expected to result in a conversion. So this measure is always not always informative, and that's why people go back to dwell time. Often is used as a proxy of satisfactory experience because they may reflect the affinity with the brand. And actually, there's a really nice paper at KDD 2 years ago that looked into this problem exactly in the context of Airbnb. When you want to book a room, is going to be a long process. It's not just the one-off, and that's why it's important that knowing what the user and how the user has explored everything is helping to do better search, because it's not just at the end the final product, because also conversion here is not going to happen very often. People are not going all over the place. Well, definitely not now, at least. Social media. There's a lot of metrics associated with social media. This is an area I haven't worked much myself, but it's important to be aware. And this actually is a nice thing that came from this site, is this notion of applause. So like, thumb ups, number of hearts, +1. Amplification, this is this sharing. This is particularly important now with the things of fake news and so on. And conversation, number of comments, number of posts, replies. And again, this is the contribution thing. So users that are into this conversation, they are the one that actually remain very active. They are the one where engagement and retention is high. So some final words, and then I want to go into the intercession. Metric for smaller granularity levels, such as viewport or specific sections. So I didn't really discuss that. Okay, we try to optimize maybe a part of the page or the whole page and so on. So it's important to be aware of this. And the other thing is scrolling. A lot of our application now is scrolling, especially in the context of mobile. And what does it mean? How a lot of this relate to that? There's also this notion of users don't like to scroll that down, at least in the context of desktop, but in the context of mobile is a very different behavior. And whether an introsession metric belongs to involvement, interaction, or contribution really depend on the expected type of engagement on the site. Okay, now going to the non-intrasession metrics, since there was some question about it. So we're going to talk about intersession metric, notion of habit and loyalty, because this notion of habit is something that I find particularly intriguing. And it's really about how many users and how fast they return to the site. There's the total user use measurement, the total use measurement, which is about popularity. And then I will talk briefly about lifetime value. So we may be maybe 5 minutes more than planned for the break. Okay, so intersession metric. Why do we need intersession metric? It's simple. You may have an A/B test. You have the metric moving to the direction you want, but it's really not working. So this graph is a bit of an exaggeration. You launch something, everything goes down. Usually you stop, you revert. But often what happens, you launch something, it goes up, because often confusion and so on, and then it goes down again. And then what you really want is like this gradual engagement. So when you want to understand happiness of user, satisfaction of user at the session level, you have to always, what does it mean for the longer term? And that's why I always related this to intersession metrics. It's a must. And this Ron Kohavi is an expert in talking about how to do this with A/B tests and so on. And this is a really good book, a good paper already in 2012. And he has a book out, which I think I will add this, which is really good. So how does this relate? So you are visiting, you are doing something on the site. There is the next session, which is this notion of absence time, which is where the habit come into account. And then there's the next day, the next week, and so on. And this is this notion of loyalty. So those are the kind of, what we mean by intersession metric: total number of sessions, total number of day active, total number of clicks. And the idea is how we relate the measurement of the quality of the experience now to those other metrics. And Youngji will talk quite a lot about how to do this. So you have the intra-session metric and the inter-session metric. You're going to look at correlation and causation. There's already some work, for example, looking at reinforcement learning that try to get this, and this will be part of the second part of this lecture. The example I gave with the ad quality, where long click, user not bouncing back, was a strong proxy of satisfaction because user click on ad later. So this is, for example, looking at those correlation and sometimes causation. And what I want to say is this notion of habit, the next time you come. So this is really the new one. So it's not this, it's really a next session. Is developing this notion of habit. It's related to endurability. It's periodicity is a short task and visit. It's different to revisit rate, and it's different to a task. And this is research I'm particularly interested. So I'm going to talk briefly in terms of search with the absence time, to give an idea of some of the work that has happened and how it can be done. And then I will go briefly with the LTV and finish. So we have another 10 minutes, I think, and we'll have a break. So absence time applied to search. So this is work that was done in the context of Yahoo Japan, which is a question and answering a search system. 1 million users, 6 ranking function. Session boundary was 30 minutes of inactivity. Example of metric for search. number of clicks, satisfaction, sat clicks, so click maybe longer than 70 seconds, meaning the user didn't come back. The opposite is quick back click, usually 30 seconds. Click at given position, where is the click? Time to the first click. Skipping, abandonment rate, number of query reformulation, and dwell time on the full result page, but also the result, the document itself, when the user actually click and end up in the document. So one way to look at time and try to predict if users are going to go is through survival analysis. And this has been used in the biomedical domain. So you have people, you give them half of them you give a treatment, and you look at the probability of survival, survival rate. With the and if you replicate this to time span, is so when you give a treatment, you hope the person live longer. And with the idea, if you didn't give the treatment, the person is likely to die sooner. If you replicate this in our context, which is a bit funny, but is if the user come back quicker, the user dies. So return to the site is short absence time. And so in this graph, if you see the red one, historic 2. So the one at the top it means the higher the line, the higher the probability of dying, which mean here short absence time. So something in story 2 make user come back quicker compared to all the other stories. And this is the idea of using survival analysis. You do treatment, you do something new, algorithm, new UI, and you want to see how does it change user returning. And those are interesting results. So with this approach, high hazard rate is when users die quickly. Again, we want them to die quickly, it means short absence time. So if you look at how absence time relate to number of click, where here the H0 mean no click, and the and more or less higher value means shorter absence, and this is what we look for. So if you look at this, what this means is everything is better than no click because everything is up there. Click between 3 and 5 results leads to same user search experience. Remember, this is not web search, is query answering. Click on more than 5 results reflect poor user search session. User cannot find what they're looking for. It's because when you have 5 click, you see the hazard rate actually decrease. So the absence time is longer. And using similar things, we also observe that clicking lower in the ranking suggests more careful choice from the user, so shorter absence time. Clicking at the bottom is a sign of low quality. So if you have to go at the end, the ranking was not good, longer absence time. User finding their answer quickly, so time to the first click returns sooner to the search application. So again, shorter absence time. And what was interesting is returning to the same search result page was worse user experience than reformulating the query. So you have your result. If you have to return, is worse than if you already have an idea why you got your result and reformulate a query and go next. And those results, to some extent, are not totally new. There's been a lot of work in the context of search that identifies similar things. And I will skip it. And in fact, people at Microsoft took this and applied to Bing. It's different search, different expectation. It's a much more varied type of search query. So they had 21 experiments carried out through A/B tests, and they use absence time as a way to maybe compare the A/B test. And they agree 60% of the time they agreed in terms, okay, the metric, which was click-through rate or something else here. And again, the positive indicator, one more query in a session, one more click in a section, the sat click query reformulation, and negative was abandoned session and quick backlink. So those are not new, but they relate very nicely to absence time. And this is why absence time is a good proxy of endurability. It relates to a number of known indicators of positive search experience, and those are the one maybe that can be used as intra-session metric, and also they can be used in the ranking algorithm. So again, absence time is a small inter-session metric. You find what increase or decrease absence time or help into that. So those are the indicators then themselves you can use as intra-session metric, including within the algorithm. So this is how it kind of relates. And this was in the context of news similar results. Okay, 5 minutes and we have a break because I also need a break myself. I want to talk popularity and long-term value, and I will conclude. Popularity metrics are with respect to user, how many user, how active they are, monthly active user, weekly active user, daily active user. Stickiness is measured by daily active user divided by monthly active user. So the more days user are on the platform, the service, divided by months, there's this notion of stickiness. And a lot of things that is important to do is to look into, to segment, to dive down into demographic platform recency. And then you have the other way, is the total usage, independently of the user. So this is further aggregation and so on. So one respect to user, one respect to usage, they kind of correlate. But there's also another way to look at it. And the long-term value LTV metric. So this is how valuable different users are based on lifetime performance, value that the user is expected to generate over a given period of time. And this is used in the context of service that rely on advertising revenue, service relying on actual purchase, and service, for example, relying on content being consumed and entertainment. And the idea here is, for example, in e-commerce, you will look at the amount of purchase. So this will be one metric that is used as part of the LTV metric because there's a cost associated with it. So for example, in that in the content of like customer acquisition cost, so that how much it costs to bring customers. And this is often added into the LTV formula to come with the LTV metric. If you are producing content, if you're producing exclusive content, what is the cost associated to it? If you are licensing content, what is the cost associated to it? Because, and you relate this to how the user is going to consume that and so on. So that is the idea with respect to the long-term value. Okay, nearly done. How does this relate all together? So online engagement and metric, day one, acquisition, returning user. Then we go into more the user being active, the period of engagement, what is happening within the session, 3 levels of engagement, involvement, interaction, contribution, how to optimize. We're going to discuss this later. When you aggregate all the metric, this is where you go into popularity. Involvement, interaction, contribution are intra-session metric. We need to relate this to inter-session metric with the idea of maybe forming habit, then itself becoming, transforming into loyalty. I didn't talk about disengagement and re-engagement, but there's some process into it to bring back the user or to ensure they're not going. And then even the bigger picture is this relate to something else, popularity metric, which of those are going to be metric to optimize machine learning algorithm, how they relate to key performance indicator, and I briefly discuss a long-term value. Okay, I think we are good for a break. I'm not too bad, only 5 minutes ahead. So, is that question?
No question, but with that, She, by the way, really appreciate her providing a lot of additional references in the papers, in the chat. And she also is saying, I really like introducing a bit as a step before loyalty. It captures whether a user is intentional about using a product or coming back to it due to habit. So I guess that's a comment, not a question. But yeah, no other questions so far. Yeah.
Okay, so I'm going to stop sharing. Shall we say back at, it's going to be 6 o'clock London time. You need to translate that to San Diego time.
Back to probably 10 a.m. Pacific
Okay.
San Diego time. So I'm going to cover the optimization part.
Okay,
So
I'm available
for
questions, feedback. You can contact me directly later on and so on. And I love that already some additional reference have been added. We just love that. There's always much more to learn and so on. So thank you.
All right. And folks, welcome to have. Can you folks see my screen? Okay.
Looks good.
Okay. All right. Welcome back to the session. So this is the tutorial that Monia and I are giving about the online metrics and optimization for the engagement. Just a moment ago, Monia covered the portion around how we define metrics, how we look at the different applications, how we think about the metrics for different scenarios and so forth. So it was a very thorough kind of an overview of the landscapes of the metrics. So in the second half of the tutorial, I'm going to spend a little bit time to talk about how do we do optimization. Before I jump to details, just a reminder, this is a kind of a high level overview. This is not going to cover all the topics, all the papers. In fact, probably would only point to various of good starting point, and the topic is usually on the ideas and the thoughts. Hopefully you could follow the different various of the pointers and the references to check out the details and also start from there to read more. So this is about the optimization. All right, so let's get jumping to the topic. So when we think about the optimization for the online metrics, I think there are two obvious approaches that we typically use. One category or one camp, I kind of organize it as a manual and semi-manual optimization. I'll definitely mention what do I mean by that in later slides. And the second camp is really about automatic optimization. So how can we do optimization in less human kind of involvement as much as possible? And the third kind of emerging way we think about this problem, which is there any possibility we could leverage these two different camps and see whether we could do both at the same time? So, as I mentioned, there are two basic camps of when we think about how do we do optimizations. The first one is what I call the manual and semi-manual optimization. So this is really about utilizing experiments, various forms of experiments, like online controlled experiments, A/B testing, sometimes we call it. But you know, the idea is really about utilizing this classic hypothesis testing, classic kind of experiment ideas, and you use that as a vehicle to optimize your metrics. So this is the first camp. The second camp is to approach the problem from a very different angle. So rather than doing experiments per se, the second camp is really focusing on, can we get a better result through optimization? So there, the notion of experiment is much less. It's more around keep improving and keep getting the better result via various of optimization techniques. I'll talk about later. So these are two camps. And as I mentioned earlier, that there is a trend of emerging topics that where folks are starting to look at how do we utilize the best from these two camps and really, trying to enjoy the good part of the both and see how we can do the optimization. So I'll mention briefly about this after that. So let's jump to the first camp. It is really about the manual and the semi-manual optimization. And here I'm going to talk about some notion of the online experiments and offline experiments and observational study, and really give you the overview about how do we do optimization in this camp. Again, these are just high-level pointers, and please go to the referred papers to look at the more details. So what do I mean by manual optimization, right? So here is an example of a procedure where we do manual optimization. So think about the metric, right? Think about the either the intra-session metrics or inter-session metrics where ammonia mentioned. And think about the one idea you want to improve that, right? So that could be, say, hey, I want the different color of the button. I think that would make a difference, and so forth. Or the color would make a difference. I don't know which color, but it could be different colors. It could be red, it could be blue, and so on and so forth. So that is really a hypothesis. Then after some discussion with your product managers, with your engineers, you choose, say, hey, a particular color, red, let's say, and then you launch an online A/B test, A/B experiment to test that idea, right? And then you monitor, you measure, and you think about, let's say the metric you care about is conversion rate. Then you take a look at whether that color of the button would increase the conversion rate. And if it really improves, it means that idea works. You go back, you choose another idea, and you keep going. So this is on the very high level what the manual optimization looks like. And if we're paying more closer attention to this procedure, right, then you will see a couple of places are manual. So the first step is manual. You have to think about a hypothesis. It's not coming from somewhere automatically. It is from domain expertise. It is from engineers, product managers, designers, data scientists, and so forth. You name it, where these folks have the pool of ideas, so then you can come from. The second step, again, it's manual, where you choose a particular realization, and that realization may or may not work out due to the A/B testing, but you have to, you have to work it out. Launching an A/B test, you typically, in some companies it's completely automatic, but in a lot of companies, it's still kind of a manual. You have to implement the idea, you have to do various of things and launch the A/B test. And the fourth step, monitor, measure, conclude. You have to, look at your dashboard. You have to make sense of some metrics, and so on and so forth. And the fifth step, realization improves the metrics. Well, you have to do some analysis. Some analysis are more obvious than the others. but you typically, a product manager or decision maker has to make a call. Okay, this really means improve the metrics. So you can see that each step is manual, more or less. And there are two loops that in this procedure, if you pay closer attention. So step 2 to step 4 is inner loop. So that means within an experiment, within a realization. So you want to try out different realizations of the hypothesis. Step 1 to 5 is outer loop, meaning different experiments, different hypotheses. So with this kind of two for loops, and we are going to improve our metrics. So sometimes it is called data scientist ascent in terms of the improving the metrics, because it is really human in the loop to improve the metric. And this is a very, very typical way we improve the metrics in a lot of companies, in a lot of different products. And this is a classical way we do it. So jump into the online experiments a little bit, right? So for those, I think everybody is very familiar with the idea of online experiments. And here I just do a very, very quick overview. So the idea is basically split the traffic of your site into various of portion, and you have a notion of a control, you have a notion of treatment, and you show control and treatment to different traffic, different users, and then you measure the difference of the metric you care about. In previous example, right, where you measure whether the color of the button make any difference in terms of the conversion rate. And then you make some conclusion and do some, you first do some statistical analysis and make a conclusion, and then that will add one step into your metrics improvement. Then you do it, remember the outer loop, many, many different steps.
So Liangji, there is a question. You used the word realization in the previous slides. Can somebody ask for an explanation?
Right, so the realization, so think about this as the hypothesis could be the color of the button would make a difference, right? The realization is in this particular A/B test, because you need a control and treatment. In a typical way, you say, oh, okay, I tested one color, right? And if that fails, if that doesn't improve your metric, you test another color, right? But this, the different color is one realization, right? So this is one example of the realization of the hypothesis. That really means a smaller granular of the hypothesis, or some of the parameterization of your hypothesis that you want to test out. But that's not completely change your hypothesis in the sense that it's still the color, right? So it's not the shape, it's not, say you don't need the button at all, and so forth. It is really a way to organize the different ideas around your hypothesis. Okay, so this is online experiment, right? And as Munia mentioned, Ron Kohavi and several co-authors this year actually, 2020, has a really good new book regarding all the nitty-gritty details about the online controlled experiments. I highly recommend you to read. So here we won't repeat all the details regarding how do you conduct a successful online control experiment. And the importance of the online experiments gaining more momentum in the recent years, right? Here is, again, very selected references that I just want to show you that even in the past 5 years in forums like KDD, www, SIGA, there are frequent tutorials regarding the online controlled experiments. And part of that is because it's not that easy, and there are a lot of pitfalls, there's a lot of challenges that to conduct the online uh, the experiments. So again, we won't dive into those details here. But if we really think of zoom out, right? So why we want to run controlled online experiment? Well, because this is the step we make sure that we kind of confirm that the idea, the realization of the hypothesis that really improve the metrics. And there are a couple of advantages with the benefits of running such an experiment, right? First of all, as I mentioned, there are a lot of classic tools and a lot of books already available to help you to understand how to do it right? How to set up the settings properly. And even in this new book I just mentioned, there's chapters around how to split the traffic, right? So sounds like very easy, 50-50 split, while in industrial implementation, that's not that straightforward as well. So there's a lot of gritty details there. So that is the first benefit. The second benefit is it is really about a nice kind of characteristic or property that come with the idea of A/B tests, right? So or with the hypothesis testing, which is the difference of the metric that we care about between the control and treatment group. It can usually link to a concept called average treatment effect in causal inference. And the difference there actually can be explained as the causal effect of your treatment, on the outcome, right? So meaning like back to this color of the button example. So if there is a difference in the conversion rate, then with certain assumptions, you could conclude, say, hey, that is due to the color of the button. So this property is really nice because that gives the decision maker, right, or practitioners an idea like how exactly your idea would improve the metrics. And you like that explainability, you like that transparency of how good, how bad your ideas are. So this is a really nice and come with the online experiments. And as I mentioned earlier, right? So it even though there's a lot of challenges, but relatively speaking, it is easy to implement. And nowadays, it becomes a standard to a lot of practitioners, even executives, and a lot of general audience as well, right? So these are the benefits. But it also comes with a lot of challenges, like a hidden challenges or some not that obvious challenges as well, right? As I mentioned, it is not very straightforward in a large scale, in industrial scale, to conduct a valid and meaningful online experiment, right? In fact, in almost all the bigger companies, like Microsoft, Google, Facebook, LinkedIn, Spotify, many other more, you name it, have specific teams, department to engineer, to implement, to monitor, and to create the tools to launch, to monitor online experiments. So meaning that this is a full-time job. It has a lot of details and very easy to go wrong. Secondly, it is really about the online setting. There are a lot of occasions where you easily run into situations where you violate the basic assumptions, right? So one typical example I have often seen from product managers and other folks as well is once you launch an experiment, you keep watching the results, right? You keep monitoring every day. Every morning you jump to the dashboard and see, okay, whether my conversion rate make a difference or not. Well, that may be a behavior that is not encouraged, right? So then, in fact, there's a lot of already papers and results talking about how that, how to correct that and so on and so forth. So that is another challenge. The third challenge is once you start to monitor so many different metrics, um, then it's going to become puzzling to interpret certain results. You know, certain result may not be that obvious anymore, right? So, and you need to you know, scratch your head quite a bit to make a sense of it. And in fact, we're going to talk about this in a minute. Um, and the last but not the least, it's even more challenging when you want to run many different experiments. So remember the manual procedure I introduced a little bit earlier, right? So there's an inner loop, there's an outer loop. Outer loop meaning you run many series of experiments. That's very typical. That's a, you know, classic way we do it. But you may run into a false discovery rate problem, meaning that a lot of things you feel or you through the dashboard that tells you conversion rate uh, is truly improved. That's probably not the case. That's probably due to there's some randomness going on in the overall kind of procedure. So that creates the even further challenge to understand all these things. So for the latter part, last year, right, there was a very nice KDD tutorial on the sequential experimentation. So there, Aditya, so he characterized the inner loop and outer loop, and there's a lot of discussions in his tutorial regarding how to correct, you know, p-values and so on and so forth in the both the inner loop and outer loop. So please check out that tutorial from last year. But even, you know, just because there is a tutorial that will tell you that this part is challenging, right? So this is not that straightforward. So here, I want to show you some of the tools regarding interpreting result from puzzling result from online experiment, right? So because remember the manual procedure, so there is, you should be able to conclude whether the matrix is improving and so forth. That part is sometimes not straightforward. So this example I'm going to use is from Etsy, this e-commerce platform, where there's you know, there's a lot of modules. And remember, I mentioned a little bit earlier in the first half, where what we care about is conversion rate, whether you buy stuff, right? Whether you buy a particular goods and or whatnot. But there is a lot of interplay between different modules, right? As you can see, there's many different pages, many different modules. Which module, right? Which page actually contribute to the difference of the conversion rate? That's hard to say, right? So this is a part of, like, how can we make sense of the result? So this is a work that we published last year in KDD, which is really makes sense of the search and the recommendation ecosystem. So let me motivate the work a little bit more, right? Imagine this is a one A/B test of your one of the recommendation modules on the page, right? So remember, there's some different modules, and what we care about is a session-based revenue, or let's say conversion rate, but let's say revenue, right, as a representation of the metric. In this particular case, we launched a new algorithm for a particular recommendation module. And from that one module, we see 5% more clicks in the treatment group versus control. But we also observe 3% decrease in the search result page. And overall session-wide revenue is kind of flat. Okay, so this is where I mentioned once you started to monitor many different metrics, you will easily run into these situations from time to time. And if you are a decision maker or a product manager, right, then you start to think about this scenario. First of all, you know, it's good that if you are engineer working on the recommendation module, right, so you see that there's a 5% lift of the clicks. So that may be indicating that your recommendation, new algorithm is improving. And the improvements usually come as a result of series of result, A/B tests, right? So in this particular case, if we don't launch it, you may lose that opportunity. That 5% gain may not retain in the future, right? So if we don't launch it, so that's one of the ideas, like not shipping this kind of early stage results might lead to some sort of the suboptimal user experience. On the other hand, you could also argue that since revenue is flat, and if you really only care about the revenue, then this might be a placebo kind of result, right? So meaning there is no fundamental change of the user behaviors, and this 5% clicks more may not good to your business, right? Because if you care about the revenue, so you might get puzzled in this scenario, right? Similar scenario, another new algorithm we launched. In this particular case, you get much less clicks on that module, okay, but you get 5 more clicks in the search result page, and overall revenue is 1% up, okay. So in this case, you also maybe get puzzled because if we launch this, then it may impact your recommendation module, because your recommendation module has less clicks. And in fact, if we launch it for so long, it may damage your training data for future iterations. So that is something you might want to avoid to do, and so forth. And also, you could argue the other way, right? So not shipping this result may lead to suboptimal result because it's good, 1% plus revenue and 5% improvement in the search page. So we should ship it. And this could be also a procedural result, right? Because this revenue may not be truly improved. It might be a false positive. So how do you know, like from this one example? So this lead us to a problem where we want to understand the interplay between different modules on the site with regard to session-wide metrics. Okay, so this later part is very important because conversion rate, revenue, these things are not from one single module, right? You can't really easily tell that is from your recommendation module or search result page. It's actually from the whole session, or the modules contributing in various ways. So, so here is really trying to tease it out, right? Tease that apart and see, which individual modules would contribute to the final result. Now, if we can understand this, then there's a couple of opportunities, right? So obviously, once we understand this, then we can make a decision. That's the first step. Second step is once you understand this and give you some insights, you could improve, you could develop certain strategies to improve your various modules and see how they can tie back to your overall session-wise user engagement. And the last but not least, then in future, you might develop automatic or machine learning algorithms to do that. So in this talk, we're going to trying to establish the first step, right? So trying to understand the result. So the result is, the idea is like this, right? So we assume, we come up with some assumptions about what's going on. The assumption is really some kind of you can think that as a causal graph, right? So in this particular case, we assume that both the recommendation module and the search page would impact conversion rate, right? not only they can directly impact the conversion rate, but between them, there's some further links that interact with them, right? So that is what we call induced changes, right? So meaning like you change recommendation module will indirectly impact your user behavior on search result page. And from there, that will finally also reach the conversion part. So then there's a direct way from the recommendation module impact on the conversion, and the indirect way via search result page. And what you observe from the A/B test is the final outcome in terms of the conversion rate or the revenue, right? You don't observe the direct impact from the recommendation module. You don't observe the indirect impact from search as well. You only observe the combo, right? So they all combine together in some sense. So this work is really about how to tease them out. But first, you have to come to this kind of a causal graph, meaning like you assume what is the underlying kind of mechanism that all these modules play together. So once you have this causal graph or the assumption, then in the statistics and economics, there's some common tool that you can leverage, which is essentially, right, to split your average treatment effect, which is the things you observe from A/B tests, your session-wise revenue or conversion rate into two parts, right? As I mentioned, one is the direct effect from recommendation module, the other is the indirect effect via search module. And here, the tool we are leveraging is called causal mediation analysis. So there is a school of such literature that to tell you how to do a formal statistical analysis to do this kind of a thing. Okay, so we're not going to dive into that part. But the key idea here is that we're going to kind of tease apart this average treatment effect into two things, right? One is called average direct effect. That's from our recommendation modules, right? With respect to the revenue, with respect to the conversion rate. And the second is called average causal mediation effect, which is that indirect measurement, right? So indirect measurement about the induced change. So all of these, right, ATE, like average treatment effect, ADE and ACME, have been studied very, very extensively in the literature. So you could possibly just apply those things in the data we have from online. But there are certain things are kind of violated from the classical setting, right? So one thing is it's so-called you can have unmeasured causally dependent mediators. In other words, you can have other things than the search result page, as a mediator, right? And that's very, very hard because on the website, there are a lot of different modules, a lot of different other pages. So how can you take all of them into consideration, right? So that is the part that we extended the work and to incorporate this idea to account all other modules and the pages on the website as potential mediators, and then we work out the way to split the effect. So again, please check out the paper, and we also have the Git repo. So check out the code. So the slides is already shared, right? So you could directly go to the GitHub repo and to apply the tool. So how about we apply the tool for the experiments I mentioned earlier, right? Now, in this case, what we observe is ATE. Remember, we observe ATE from A/B test result. So in this case is a recommendation module experiment that bring up 0.22% conversion rate improve, not statistically significant, and minus 0.25 in terms of the what we call the generalized merchandise value, you can think that is a revenue. So that is what you observe from the dashboard of your A/B test. Now, by applying the tool we just mentioned, you get the generalized ADE and generalized ACME, which is really the contribution of the recommendation module and the search result page. The direct contribution of the recommendation module and the induce the change of the search result page with regarding the conversion rate and the GMV, right? Now, in this case, you can see that the direct effect impact of the recommendation module to the conversion rate is very big, is like around 0.5%, and it is statistically significant. While at the same time, the indirect, the induced change to the search result page is minus 0.27%, and very statistically significant, right? So this result won't be possible if you don't have the tool in hand, because you can only have the direct measurement, like a clicks on the modules. You won't have the contribution of the of these modules towards your session-based metric. So this tool give you that, right? So this in this table, you can see that the result, and it is causal with regarding the assumption that we make in the causal graph, right? So remember that graph that I mentioned earlier. So with the result, you can start to make some decisions, right? So then you can say, hey, ATE is flat, but the recommendation module significantly improved. So you could say we hold this, but you also could launch it because there is indeed a positive impact on the from the recommendation module. Second result, as I mentioned earlier, right? Again, it's very, very similar, right? So, but in this case, the ATE is significant, right? So the ATE is significant. Then you also see the recommendation module is significant impact the conversion rate, and it has a slightly negative impact on the search. So this is more positive than the previous example, and you confirm that the improve of the conversion rate is indeed from your recommendation module, and this is a positive move. Okay, so again, this is just a snapshot of the result from the paper, right? But basically, this is the first step where you can derive direct and indirect effects on different modules with regard to your session-based metrics, right? And then you can tell the contribution from these different modules and whether they are making contribution to the increase or decrease, right? So this is remember back to our online experiment kind of the setting where we want to improve the metric, and this is giving you the evidence whether the module, whether the new algorithm is improving the metric. So to give you a recap on the online experiment part, right? So again, I won't go over all the details again, but the key idea is that there's a lot of nice properties, a lot of good tools are available for the online experiments, and this is a very classic setting that we utilize to improve the metrics. On the challenges part that we have for the online experiments, it is really about how to make it right, how to do it meaningful, how to make it right, and we also see that even sometimes reading the results need additional tools, requiring we do further analysis. But nevertheless, online experiments are kind of a cornerstones to utilize to improve our online metrics. So go back to this manual optimization, right? So as we can see,
I have two questions for you.
Okay.
There's been quite some discussion also on the chat, but I'm just going to go for the two questions. So the first one, for the two examples, the indirect impact from search is negative. Are there any ways to solve the issue?
Yeah, this is a great, you know, question, right? So again, we kind of develop this tool and apply to different experiment results, and we start to always see some interesting interplay between the recommendation modules and the search result page. And typically, they are like one positive, one negative. So meaning like from the user intention perspective, there might be an interesting user behavior that they switch between the getting recommendations mode to the search mode and so on. But we haven't got any further kind of analysis there and the ideas there. So I think these are the nice future work where we explore the different modes of search and discovery, and whether there's a happy land where both recommendation and the search results are positive. I think my guess is there are, but it's very hard, probably hard to search where that nice spot is. But this is a really good question.
The other one is in that case, ATE, the case of ATE, does calculations need to monitor control group of search module?
Monitor control group. Right, so that's a great question. So the ATE, remember we talk about the average treatment effect that we care about is session-wise revenue, right? Now you get that for the search, for the e-commerce, you get the purchase once you have the cart, right? So you add things in your cart and you check out via your cart. Now, remember I mentioned earlier from the search result page, it's not that obvious where one purchase is 100% contribute to a search behavior. A user search something, then they can do something else, and so forth. So just dive into the search population is one way to look at the problem, but also sometimes you lose the bigger picture, right? Because you want to improve session-wise the session-wise behavior. So, but that you typically you would also dive into a subpopulation as well. Now in this case, we are focusing on the session-wise conversion rate and revenue.
Okay. There was a discussion also around. So when you talked about there's many metrics to consider, and there was a question how do you choose metrics? Then there are primary metrics, guardrail metrics, but there was a discussion in context of search where there's a lot of metrics that are looked into also from a monitoring perspectives. So just in making sense, and a lot of them are kind of related to proxy or search satisfaction. Some of them will include other things. But it's we'll briefly talk later on about guardrail metric, which is a little bit different problem. But you continue.
Probably I have to speed up a little bit, but go back to the menu optimization, right? So as I mentioned earlier, these are the different steps of the menu. Okay, so obviously the biggest challenge is how many such ideas we could test, right? So as a website, there's a limited traffic. You could split up your into the A/B test. Of course, there are more advanced techniques where you can share the traffic. You can do layers and different universe and so on and so forth. But still, traffic typically is very limited, and the time is limited, right? So like around your online experiment, you typically need 1 week, 2 week time to observe the result. So it's how many weeks you would have in a year. So this is significantly limit how many ideas you want to try out. And in order to improve the metrics, sometimes that's bounded by how many such ideas, right? So like, you want to try as many ideas as possible. Another big challenge is once you do the experiment, you throw away the data, right? So there's not too much reuse of your data. So, but a lot of data and a lot of the results might be useful, right? So you test out the color of the of the button, the yellow color, that experiment maybe failed, but that data may be useful to determine whether red or whether orange would work, right? So why not just utilize some of that data? So with that, we go to some semi-manual optimization, right? Now, in this case, you start to utilize a thing called the offline experiments. Now, and also you move to the domain where you want to test out a family of hypotheses, right? So like, as I mentioned earlier, maybe you test out all the colors offline, you utilize some data in some form. And then you choose, there's some procedure that give you the idea to choose which one from your offline setting to launch in A/B test, and and doing the pretty much exact same thing as manual step, but the only thing is to add the capacity, right? So you want to improve your throughput. And this scenario is nothing more than just, I think, a very good classic machine learning textbook scenario. Right. So what I mean by that is in the offline setting where you kind of have a training, validation, and somewhat the testing, right? Offline testing, and you treat it as your machine learning kind of practice, and you iterate to optimize your ideas, optimize your some metrics, and you launch that in the online setting, right? So this is again a typical supervised learning kind of a scenario, and you can also do cross validation. You choose your parameters, so on and so forth, and you view your online experiments as somewhat extension of your offline optimization, right? So as in a lot of cases, treat it as an extension of your test data. Now in offline setting, right? So then you start to think about, okay, what can we, once I have a way to gather my data, can I really optimize my metrics, right? So in a lot of, there are two ways to optimize your metrics in an offline setting, right? One way is to directly optimize it. There is a way you can write it down in a very clear form, and you derive your machine learning mechanism to optimize that. So that is one idea. It is not always possible. In fact, in most of cases, it's very, very challenging. But there are, I think, a handful of cases that it is possible that you can write it down. In a lot of cases, it is very hard to write it down. You don't even have the data, and you cannot easily deploy such systems. But I'll mention one example where we could write it down, right? So this is one example where we want to optimize the revenue, right? So remember I mentioned earlier, the previous work is about understand the result. Now this one is really about optimize the revenue from our search result page in e-commerce. Now, I mentioned this briefly, right? So we have this notion called gross merchandise value. It's called GMV in the e-commerce search. And what GMV, if you can write it down, it is really about probability to get purchased times it's kind of a price, and you sum over all the sessions, all the items, and so forth. So this is the GMV you have. Now, for a user to get a purchase, to contribute to the GMV, we can simplify the procedure into two steps, right? First is they get to the search result page. In this case, they type the rosy wedding dress, and then they click, they find, first they need to compare, right? So on this page, which one they like, and then they kind of click that item, right? So then they jump to the detail page, right? So that's the product page. And from that product page, they make a decision. They make a call, okay, this sounds like what I like to buy. So this is a very, bare bone of the decision, the purchase decision process, right? So this is definitely very simplified, but this is a kind of the what's going on basically. So if we think about it, then we can say, okay, can we write it down in some form, right? So can we describe these two steps into some kind of mathematical way, right? Now, in this particular case, we are saying that we decompose the decision making into two parts. One is from the search result page, you need to click, right? So which one to click? That's a click model. Then once you go to the search result page, then you would have the purchase model, right? So you make a decision whether you want to purchase. Let's talk about one by one, right? In the click model, essentially, we are utilizing the list-wise kind of search, the learning to rank. So meaning that we want to optimize NDCG of clicks on the search result page. So here we have the measurement of the NDCG, and then we plug in our FC, which is a click model learned via a neural network model. And then really here is to optimize NDCG on that search result page, right? Again, details, please go to the paper to check it out. On the purchase decision page, right, so on the listing page, what we have is a binary kind of a decision where we want to optimize how likely a user is going to purchase this thing. Now, in this case, it's just a logistic regression. Now, in order to kind of regularize with very high or very low price kind of items, we regularize with price-weighted logistic regression. And then basically, right, so go back to here is when you plug in two models there and kind of jointly learn the model parameters in both of the click model and the purchase model. So we tried it on the Etsy kind of a search data, right? So these are some characteristics of the data set we tried. First of all, we kind of see that this kind of the e-commerce search has a very different kind of a characteristic than generic search, meaning like if we measure the position kind of bias, there is actually more granular bias, meaning it's not strict power law, but the decay is more granular from different positions. So users are paying more attention to various of positions, and we utilize a lot of features and different kind of the learning models as well, right? One is how about we fit click model and purchase model separately, right? Or just fit the click model or just fit the purchase model. Now in our case is how about we fit both, right? So then we compare all of them. Again, not spend too much time here, but a nice kind of takeaway is that Lambda Mart actually works pretty well as a kind of off-the-shelf state-of-art learning to rank model. In fact, you just optimize click, it's already kind of giving you reasonably result in terms of both click and the purchase result. So meaning if you don't do anything, just train your Lambda Mart against the click table, that will give you reasonable kind of result. This is where like 0.14 here, right? But if you want to get additional performance, especially for your purchase decision, and especially and in the end the GMV, like the revenue I mentioned, then you have to do both. And in this case, our model performs much better than the rest because we optimize for both models. And there's a more result due to time limit. I'll skip. So this is one work where we actually try to write down GMV, right? Try to optimize GMV by, describing the procedure in a session. Then you can ask questions like, okay, can we do it across sessions, right? So like, if we want to do, optimizing long-term GMV, how can we do it? How about the discovery, as I mentioned earlier, right? So for e-commerce purchase, discovery and inspire users are very important. How about those metrics? So these are definitely good future work that folks could explore. But this hopefully give you an idea like what do I mean by direct optimization, right? So meaning somehow you could write down the procedure, user behavior procedure, and somewhat you can convert it into some machine learning algorithms and to optimize that. A lot of times, that's not possible, right? A lot of times, most of cases, probably that's not possible. So I think Monia mentioned earlier in the first half is what we typically do is to optimize certain things within a session where it's easy to optimize, and hopefully that has some idea, right? So that can lead to intersession and maybe even long-term metric improvement. So this is the this part of the work. Now here really depends on what is that proxy metric you optimize, right? So because you optimize some surrogate, and hopefully that will lead to some intersection, metrics gain. So that really boils down to how do you understand this proxy metrics, and and also possibly derive some correlation or causation relationship with long-term metrics. So first, let me talk about one work where we have the correlation relationship. So this is a work where we did back in Yahoo, and this is really about trying to utilize dwell time as that proxy, right? Now, for dwell time, there's some, a lot of like a kind of nice properties of the dwell time. So for instance, we look at the dwell time of different devices, right? Now, in this case, is desktop, tablet, and the mobile, and you more or less see they have the same shape, right? So there's some peak, there's some kind of a long tail, but you also can see they're not exactly the same. Like they have different behaviors on different devices. Also, if you look at the article length, this work is really about news recommendation, right? If you look at the article length on different devices, then you also see the dwell time, the average dwell time differ quite a bit on different devices. And obviously desktop, on desktop, users would read much longer, right? So than other devices. And number of photos as well. Again, I'm going to skip some of this result. Now, one thing we discover is that before you even do anything, right, because of all these differences, that convince us that you have to somehow normalize them across different devices, right? Now, we kind of normalize everything with regard on desktop. So meaning like we align the distributions on different devices to the desktop such that we are doing some apple to apple, some comparison. So that's some of the pre-processing we have done with the data, right? And then what we did is we actually tried out, can we optimize this dwell time, right? And can we optimize this dwell time? And hopefully there's some change in our business metric, right? And in fact, we achieved that. There are two things we have done. One is to directly optimize dwell time as a target, like the label of the machine learning algorithm, and the other is using the dwell time as a weight, right? Both actually had a very good result and outperform. We use click as a way to optimize. In fact, we launched the online A/B test and see significant and consistent better result if we optimize dwell time. And then we are discover, okay, dwell time indeed correlate with our business metric. And then we start to utilize dwell time as a surrogate, right, as that proxy. So from that time, optimizing dwell time becomes a de facto method, even though it's not optimizing the business metric directly, but it has a nice way that we observe they have some correlation, right? And then we started to report this and optimize this. Remember, this is from observation, right? So there's no kind of proof that the dwell time cause the business metric increase, but we observe this correlation and track this correlation from multiple quarters, and that convinces us that this is a nice proxy metrics we optimize at that time. So this is dwell time, right? And this is really about finding a matrix, proxy metric. Let me talk about one recent work we have done regarding establishing some causal relationship, right? So like, okay, that's dwell time, correlation, observation, really nice. But what if we didn't discover dwell time, right? What if dwell time has weak correlation? So how are we going to do, right? Is there any way systematically we discover all these metrics? So recently, right? So actually, just in this KDD, we have a paper from Etsy, my former company, some colleagues and interns we did, which is to discover some such a causal path from the algorithm to business, and really want to tell whether there is such a causation, right? And the setting we have is like this. So remember the offline online experiments, right? So in offline experiments, our machine learning models are optimizing things like NDCG, MLR, MAP, right? So like this GMV algorithms that we put out there, right? So, so this is our where you train your models, you tweak your model, and so forth, and then you launch it online, right? Once you launch it online, you started to observe some online evaluation metrics, right? In this case, probably like online NDCG, MLR, MAP. These are the metrics you can tweak, but you can observe from once you launching the your algorithm, right? And you can see they differ from your control and treatment group and so forth. What you really care is your in some of the case, right? Your site-wide GMV, right? Your site-wide revenue. Okay. Now we want to build a link, right, between our machine learning metrics, NDCG, MMR, MMP, and so on and so forth, with respect to our business KPIs, right? So GMV and so forth. So this work is really this red arrow where we want to establish some causal relationship. What does that mean? Okay, what we want to derive is how much business KPI would change for a 10% increase, let's say, of our NDCG, right? Our newest machine learning model improved 5%, 15% of NDCG, and we want to translate into, the change of the GMV, right? Revenue. If we can do that, that'll be great, right? Then we can have some evidence to guide our, product evolvement. So if you think about this, right? So a naive idea would be, okay, we want to see the difference between the NDCG, online NDCG and the difference of the GMV, right? Can we do some experiment? Can we tweak the online NDCG, right? Let's say somehow we keep the control NDCG as 0.7, and we somehow tweak the treatment NDCG to 0.8. There's a 10% difference. Then we observe the GMV difference. That'll do the work, right? Well, theoretically, probably yes, but it's very hard, right? Because like, how do you tweak your online NDCG? That's due to your machine learning model. So you can't really do it as an experiment. So you can't really launch an A/B test to test out this causal relationship. And also, they may deteriorate your user, experience, right? So, or say you want to decrease the NDCG to 10%, right? That may deteriorate your user experience. You can't usually do that. And also, NDCG is kind of a real number metric, right? It's not binary. It's not like this red color, blue color, yellow color button. It's a discrete kind of a treatment. So you can easily apply the tools that from the classic hypothesis testing, because This is not discrete treatment anymore. This is continuous treatment, right? Because the treatment, the difference of the NDCG is real number. So because of these challenges, we are applying two techniques to over these two challenges, right? One is to overcome this discrete treatment. So we need a continuous treatment. Now, in this case, we applied a idea from biostatistics called the dose response function, right? So it's like you get some dose from your medicine. And in that case, the treatment is continuous, and we apply and utilize some of the tools there to study this NDCG and GMV, right? So this is dose response function. The second part is, instead of doing A/B test, or instead of doing trying to design what kind of A/B test we can derive such a relationship, we utilize historical A/B tests, right? So our assumption is in some of the historical A/B tests, we can already have this data available, such that we can do some meta-analysis to be able to derive this relationships. So these are the two key ideas that we employed in order to derive such such relationships. And here is really about we treat NDCG, MRR, MAP as mediators, and some historical A/B tests their treatment, right, as treatment, and the NDCG as the mediators, and see how the mediators would impact the GMV. So to be more concrete, right? So let's imagine there are many different historical experiments, and all these treatments, some are the buttons, some are the algorithm changes, some are marketing page changes, and so on and so forth. All of them, right, have some effect on NDCG. In our case, is this M is a mediator, right? And all of them also have the direct impact on the final result, which is the revenue or the GMV. Now, what we want to characterize is this red arrow from NDCG or MAP to the revenue, right, from this causal graph. And we also want to take any unobserved, unmeasured mediator as account as well. Okay, so this is the causal graph that we employ. And please check out the paper for details with regard to how this result get derived. And we also have the code published on the GitHub as well. But just give you some ideas, right? So what kind of data we are utilizing? We are utilizing 190 experiments from different teams, right? So there are some UI changes, there are some search ranking changes, there are some payment changes, there are marketing changes. And first of all, we plot the kind of a distribution of how these different experiments with regard to the change to the NDCG, right? And this is really the average treatment effect. Like 0 means there's no impact, right? So there's 0 AT. As you can see that all these different teams, most of them, right? So some of them have a centered around like a 0, right? It may kind of make sense, right? So a lot of ideas won't pan out. Search ranking, as you can see, there are some very good improvement, but also some very negative ATE as well, right? So meaning like there's a kind of a wide range of different ideas that the algorithm is doing. But more on that is it kind of validated the idea where we want to utilize all different A/B tests to do the meta-analysis, meaning there's enough variations exist in the data such that we can learn the space, right? So if everything is all positive, if everything is all negative, if everything is around 0, then there's no variation in the data, so then we can derive the causal relationship. Now here it validates that there are enough variations in the data, and most of the, in fact, probably all the assumptions that we are making are, can hold. So this is a very nice validation there. So we apply this to the 3 metrics, NDCG, MAP, and MMR. I don't know whether you can see this graph. It's kind of small, but overall the idea is that we discovered their relationship with the GMV, right? Remember, we want to establish the relationship. And there are two nice things. One is all of them, we verified they have positive causal relationship with GMV. Okay, so meaning if you improve NDCG and MAP and MR in certain way, they actually can indeed translate it to dollar value of the GMV we care about. So that is one. Second is, again, not there are some details, but second is the relationship is not a linear. This is also nice, right? Because if it's a linear, then too easy. But indeed, it's not linear. So meaning like the improve of the NDCG with the GMV is non-linear. So actually the method we introduced can fit such a non-linear relationship in the causal space and really tell their relationships. So this is also a nice discovery from the work, right? So this second is a non-linear. Now, the third is that on top of that, right? So since we have these three different metrics, and we can also utilize the idea called the elasticity to see which metric is more sensitive, more meaningful to drive the GMV, right? So meaning that, they could tell the more differences in terms of the, the sensitivity. Again, so please check out the paper, and also there's a presentation, I believe, on Thursday of the detail of this paper. But go back to the high level idea, right? So by utilizing the methodology we talk about here, we can say with much certainty and much stronger evidence that saying, hey, optimizing NDCG or MAP or these metrics on our search result page indeed have a positive, and actually you can derive the dollar value of the GMV such that you improve the overall kind of metrics, right? So this is not the dwell time correlation anymore. This is more on the causal relationship that we can discover from different metrics. So again, offline experiments are good because we are improving the throughput, right? But there's two challenges. One is the correlation, one is the causation. Correlation, we have to work with the proxy metrics. Sometimes you can discover it, sometimes you won't. Causal relationships, sometimes we can derive it, but the tools I think are still new, and there's a lot of emerging ideas that we still have to work out. But again, these are like online experiments so far. So go back to the semi-manual, right? So as we can see, this is really about to improve the throughput and some of the correlation and causation kind of relationships. Now, some recent years, there's some work to say further regarding the to say some further statement regarding the offline experiments, right? Which we want to in fact put some guarantee. So this is a kind of a category of work called offline A/B experiment. So meaning not only we're doing offline experiment, but somehow we want to treat them as we are doing online A/B tests, right? It's kind of a counterfactual offline reasoning. And we really want to answer the what if problem, right? So what if I change the color of the button in offline setting, right? It's not on the online setting. That's a much stronger requirement to say certain statement. But the work actually, go back from now on is kind of almost a decade ago, right? So it's more about from the idea that how can we do unbiased offline evaluation of bandit algorithms, right? But again, the idea of unbiased offline evaluation, not necessarily tied to the bandit, but it started from there. So the key point here is that you need to have two things, right? So two policies. One is your logging policy. So in order for you to say something later in offline, you have to log, your data collection mechanism, right? So no matter it's uniformly random or non-uniform random, but somehow you have to log it somewhere, and it's called a propensity score, right? So I'll mention it in a minute. And then you gather the user feedback, right? Now, so that is a very important step. Now, in the next step, which is you try to try to test out your new idea, right? Now, in the new idea, in offline, in addition to your supervised learning mechanism, you have to consider the logging policy, right? So that is a key. So one early idea where the Li Hong and other folks apply this in a counterfactual setting for the offline, evaluation on the Yahoo homepage. And from their paper, right, they did actually discover if you do this kind of propensity related, offline metric, actually it's kind of more or less match. In fact, very nicely with your online experiment, right? Meaning that you kind of can trust your offline setup with this propensity reweighting kind of mechanism. So offline A/B test can address, right? So your data bias issue can say certain things regarding the causality, because now you kind of mimic your online experiment and can reuse your data, right? Because once you log your your propensity scores, you can derive some nice properties and so forth. Now here, quickly go over one work where you could generalize to non-uniform logging, right? So the Li Hong's work earlier is about uniform logging, meaning like you choose different items uniformly and you log it, and then you apply later, right? Now, one idea, beyond that is you actually can do non-uniform logging, but you just have to log your propensity score, like in this case, like a PI, right? So how likely an item would be show up, and then once you do the evaluation, right? So once you have the offline setup, you just need to derive that, right? So meaning like you reweighted your propensity scores. So sorry, you use your propensity to reweight, right? So you reweight your model scores. Sometimes this is called importance sampling. Sometimes you call the inverse propensity weighting. So there's a lot of different names with that. Now, this is still I think, very much a lot of good ideas already developed, but still kind of early stage of topic, right? So meaning that how can we do it effectively and not hurting user engagement metrics, right? Because now you are saying I need to uniformly, log things and show things, uniform randomly showing things and so forth. People may leave, right? So if you show just a random stuff, people may leave and they will never come back. So from the data collection logging perspective, it makes sense, but from the user engagement perspective, it doesn't make sense. So how can you do it more effectively, right? So that's, I think that's a kind of the open question to the community. So one idea, we have is, okay, so not hurting user engagement, right? So maybe you show some good stuff with some random stuff, right? So if you just completely show random stuff, people will leave. But how about, right, with their popularity, with how likely users are going to click on them, I always show some good stuff with some random stuff. So maybe that will, retain user metrics quite a bit, and at the same time, you can gather the data for your offline, A/B test, right? So this is a one idea we did back in Yahoo, which is, like I mentioned, right? So mix the good and the kind of the bad stuff, and trying to sample from there. And we launched it in a live traffic, and the good news is that it has much better performance than random, completely random exploration, right? So we can have a much better performance, and actually because of good article mixing, it's tracking the best performance we probably have, with certain kind of a gap, right? So you can actually see this green line, right? So this blue line as well, they are exploration bucket where they track with the best performing, the model with certain gap, right? Because there's some randomness, but not completely randomness because you have a good articles show up. Now, compared to the previous segment of the time where these are like more or less completely random, the user engagement, the user experience is much better, right? But still, you are exploring and get the data. I'll skip some details here. So, but nevertheless, I think this is a new area, and in fact, in the past several years, there's a increasing interest in the offline A/B testing. There are basically two keys, right? One is to get your propensity score logged, and and hopefully it's good, and also, right, so try to rewrite your objective function with the inverse propensity weighting, right, as I showed a little bit earlier, and derive your optimization algorithm. So this is really the recipe of all the offline A/B tests. This is you want to do A/B test, but sorry, you want to do offline experiment, but you want to do with certain guarantee, right? So this is more or less concludes the semi-manual optimization, right? Now, there's a last thing I want to mention a little bit earlier. Want to mention is called observation study, right? Now here, actually, you can do experiment. Sometimes you can do the exact experiment you want to do. Sometimes you can't do experiment at all, right? Now, in this case, you have to rely on some offline setting to make some statement, and then you launch it and hopefully improve your metric, right? So this is more extreme than a couple of things we mentioned earlier. This is where sometimes this is a type of online experiment may not be feasible, right? So one example where is you want to study what kind of UI change you may lead to monthly active user change, right? Now, for some experiments, you can monitor weeks, sometimes a month, but for monthly active user change, you need to monitor multiple months. So obviously, it's very, very hard to do any experiment to directly monitor such changes. So you can't do such a experiment effectively. And further, right, so what about the year-over-year changes, right? So again, you can easily do experiments. Sometimes you can do due to other reasons, right? So like, for e-commerce side, sometimes you have to launch marketing campaigns. There's some policy changes. Say you charge everybody $3 in the past, now you want to charge everybody $5. Now for those changes, for marketing campaigns, you have to sometimes roll out to the whole population as a whole, right? So for legal or for many other reasons, you can hold back and you can test out, some of these ideas. So for these, what you could do, just utilize the historical data and many other things to make a call, but you can't really do any kind of meaningful online experiment. So this is really a domain where you can experiment, right? So there's certain things it's kind of experimentable. There are certain things it's a go beyond the experimentations. Now, typically, right? So I won't go to details. There's emerging topics regarding how we can utilize observation study to optimize the things. But typically, on the nutshell, right? So you need very, very strong assumptions in order to derive any meaningful kind of statement, right? So you need a very strong assumptions, and it's very hard to derive any meaningful things for complex scenarios. Say like holiday campaigns, some policy changes. It is really hard. Okay, so quick summary, right? So for the manual and semi-manual optimization, this is really a main camp of what we optimize metrics. It is really about utilizing both online and offline experiment, right? So online experiments, A/B testing, everyone understand it, but it also have challenges to understand the details and also get it right. Offline experiments, There is a classical machine learning scenario where we could do a lot of things, but there's a non-trivial gaps between the offline and online, and also how can we derive a correlation and a causation, right? Observation study, you need a very strong assumption. So hopefully, this is a recap of the manual and semi-manual optimization. Before I jump to automatic optimization, right? So I want to also quickly mention a lot of these things have relationship with each other and tied to how a particular metrics are defined, right? For instance, NDC, certain metrics require, there's a user behavior, right? NDCG, AUC, precision recall, you name it, it requires a positive label, right? So either a click, conversion, purchase, you name it. But what if I come to the site that never click on anything, right? I just browse, I just spend time. Well, so then you may not have an NDCG, right? So then some of these metrics would have trouble to capture everything, right? So this is one part. The second part is certain metrics require a certain way to think about decomposition of the user behavior, right? So let's say conversion rate, it's typically it's condition on the impression, condition on the click sometimes. So meaning like you have to take a look of the item first, and then decide to purchase, right? So it's kind of a condition probability to begin with, similar to the click-through rate. So there is also pitfall where click-through rate may increase, but your site-wide experience is decreasing because this condition, right? So you have to understand some of these metrics, what does it mean, and how they are defined. And the last part is also certain metrics have missing data, right? So like a dwell time, view score, there are partial data to begin with. And how can we sort of, correct the data, right? So, and depending on the site, sometimes you may not be able to correct them. And you have to take this partial view into consideration, right? So these are things on top of whether you do manual or semi-manual optimization. These are just a natural kind of a natural behavior from some of these metrics. Okay, so automatic optimization. Now, this has a very different view of how you want to optimize a metric, right? So the manual and the semi-manual is view things via experiment. Automatic optimization is, I don't really care too much about experiment per se, because experiment is a way, intermediate step, where you want to make a statement of certain improvement. But I have a confidence of improving certain things. So I don't really, care too much about every mini step of improve a metric. But I want to keep, improving that, right? So I have a way to keep raising a number or optimizing a metric. So this is really about automatic optimization, where you start the hypothesis, then you just keep optimizing that. Now, of course, in this setup, we could also have an offline online experiment stage, right? So you can say, oh, I wrap everything in a experiment, and now in your control group is automatic optimization algorithm, and your treatment is another automatic optimization experiment. That is definitely possible, and a lot of us are doing that as well. And these two things are not mutually exclusive, but they could combine together. Now, the reason I don't mention that part is trying to emphasize the key idea here is to optimize versus using experiment as a way to improve the number. So how do we optimize? Well, you have to have a clear objective, right? So it could be objective, reward, utility, loss, you name it, but you need to somehow define it in a very clear way, right? And then you have to either maximize it or minimize it. So there is a very clear notion of that. And then in this tutorial, I'm going to cover very quickly about three paradigms of such ideas, right? So like online learning, multi-embedding, and reinforcement learning. to give you an idea, like what do I mean by automatic optimization. Online learning. Okay, so this online learning is more about the machine learning notion of online learning, right? So the goal is to minimize some accumulated loss, right? So again, as you can see, uh, there is a for loop. In some sense, is very, very similar to the for loop that we mentioned in the manual procedure, right? So this is where we can, kind of combine these two camps later. But I'll mention that in the later slides. So here you just think that this automated procedure is to iterate and keep minimizing the loss. And there are theoretical analysis around how good or how bad these algorithms are around regret minimization, right? So this is how we quantify how good, how bad. Now see, this has different uh, theoretical analysis compared to the experiments, right? So in the experiments, we care about average treatment effect. That's kind of basically compare two things, right? Compare your treatment and compare your control. Now here is to compare to some oracle, right? To come from what you are doing compared to the oracle and see the regret, right? So and then the theoretical analysis is to try to bond that. See, there's a very different kind of the idea, right? A very typical example, right? So again, this is one example out of many, many, many different online learning algorithms out there, right? But this is one classic example where Google used to optimize their ads algorithms in the early 20, the last decade, right? So it is called follow the regularized leader (FTRL) algorithm, where you will deploy this algorithm online, right? So it's not offline training, it's online. And then you tweak your basically logistic regression coefficient online, and you basically apply that every day, right? So the model actually changes in more or less real time because, depending on how frequently you update the model, right? Sometimes could be hourly, sub hourly. It depends on your system. But the idea is that those models, right, because parameters, coefficients are changing, in the online setting. So then it's not a static kind of A/B test anymore, right? Because your model is changing. So a lot of online learning algorithms are very easy to implement and understand. They are various form of stochastic gradient descent. Um, but as I mentioned earlier, right, so they don't have a notion of comparing multiple different, hypotheses, right? So you can't say every treating effect, naturally built in the algorithm. No, you have to wrap it, as I mentioned earlier, you have to wrap it in some form of A/B test and tell that, right? So the algorithm itself doesn't have that notion at all. So it doesn't, so meaning that it doesn't have the notion of how good, how bad compared to another model, right? It only has the notion of regret. Like that's the from the theoretical analysis perspective, how the regret uh, analysis, right? And there are like some nice tutorials around online convex implementation and so on and so forth. You could check it out. The next thing move a little bit beyond the online learning is, okay, so online learning is great, but we don't have a notion of alternatives, right? So we only have one model in general, but we don't have a lot of alternatives. How about I want to choose between different alternatives? And that in that way, I can, bake some of the business ideas, bake some of the domain knowledge into the decision making, right? So this comes to the tool called multi-arm bandit. Now here is really, you want to choose several alternatives, and you want to, at the same time, also maximize some reward, right? So similar to the online learning, here the idea is around maximize some reward, and the theoretical analysis also the regret minimization, right? So it is like how good, how bad with regard to some oracle scenarios. One work I want to mention here is we use that to optimize our intercession metrics, right? Now here is we want to utilize multi-arm bandit to optimize the long-term user engagement. I'll quickly go over the work, right? Because due to the time. So here is that there's a lot of ideas, right? I mentioned even the dwell time one, right? I mentioned earlier, is about in intra-session effect, right? So like the clicks and dwell time and so on and so forth, you directly optimize for immediate outcome of your model, right? And there's a lot of nice things, right? So about that, but also there are related work, right? Really talking about people may leave your service once they find they get bored, right? They keep watching a lot of popular items, then they get bored. So so then there's a risk. There is a risk of keep recommending popular stuff, right? Even though they can gather a lot of immediate reactions, but they may lose users in the long run. So how can we characterize that, right? So the idea here is that, is there any way we can predict uh, if we use click as a way to quantify their relationship with articles, right? So can we predict the future clicks, right? Depending on the recommendation decision we make here, and if we can, make this prediction in the future, then we want to combine it somehow in the decision making, such that we know that what kind of trade-offs we have to have to make, right? Now, of course, you could run it offline, but it require a lot of computation, and also articles come and go, and you have to somehow make this decision kind of on spot, right? So like if you do it a daily update, then a lot of articles are already gone, and new articles you wouldn't capture those things immediately. So there are there's already some work regarding modeling user post click behaviors. I think Monia also mentioned some of this in the first part. So the idea here is really trying to balance, right? Trying to balance the immediate reward and the future reward as well, right? So then we want to, combine both of them, right? So we want to make user click more now, but also return, back, as well, right? So then it's very natural. We model these two stages, or two phases, right? One is to, at each iteration, we model how immediate the user would likely to click that. Then the other is to model for all the future visits, how they are going to, after seeing this, right? So what are their expected clicks? And then we, combine it. Now, this, of course, can be formulated in the reinforced learning setting and so on and so forth. But some of the challenges here is the standard reinforced learning may not apply is because we don't know the future candidate pool, right? So like I know all the articles available today, but I don't know what news articles available tomorrow. Like the candidate pool or the item pool is changing. It's more or less unbounded. So it's very hard to quantify that, right? So that space is unbounded. So some of the standard techniques probably won't apply very easily. So we need some kind of approximations. So the idea here is that instead of modeling all the future steps, so we are doing just looking at finite steps, right? And sometimes we only look at one step ahead, and then use that as approximation for the future. Of course, it's a very strong assumption. Now, because of that, then we could use two models, right? Again, one model to capture the click behavior immediately. The other model capture how likely you are going to return, right? So that is basically model your return time interval. And, and then for both models, we combine them and apply a multi-arm banded strategy on top of that, which is upper confidence with UCB. Now, because we have two models, So we should be able to learn them, and both models are personalized, meaning the coefficients are depending on individuals. So I'm going to rush through some of the details, but just want to quickly show some of the results, right? So so comparing to different algorithms, we actually can see by optimizing, by choosing the objectives, some is directly optimizing the clicks, some is optimizing the return time, some is the combine. You see they have a huge variation of the behavior, right? Which is good. That means actually optimizing different things actually matter, right? So it actually leads to very different behaviors. And the nice thing we discover is that after deploying this model, right, so we actually can see they are recommending very different articles, right? Like in this case, you can see that if we recommend only click articles versus the articles that help user to return, you see the tag cloud, right? So the words actually are very different. So meaning like there are indeed these different elements of the articles that cause users to click or return, right? So this is a nice property that we discover. Again, multi-arm bandit, there's a tons of work proposed in the past decade. Most of them are easily to understand. There are variations of the UCP or Thompson sampling work, both. So they more or less have a similar fashion. But it's very hard to scale to millions and billions of items, right? As I also mentioned, it's very hard to scale to the scenario where you have unbounded items, and how do you capture that easily is a question. Very similarly, right, reinforced learning is very popular recently. There are some recent proposals and early attempts to utilize reinforced learning to optimize long-term user engagement. I won't go through the details, but they are very similar to what I described as a multi-arm bandit, but using the reinforced learning kind of language, they have pretty much similar challenges, right? So is how to scale to millions and billions of items. A lot of articles you read, the reinforced learning applied to recommendation, nowadays you typically see some nice tricks that boils down to much smaller scale, or that somehow the scale is not changing every day, right? So it's not like news articles changing every day or certain things changing every day. There's some way you can maintain your space, and so on and so forth. So that is the key. And also, how can you derive your long-term metrics, right? So like which metrics you optimize. Once you know that, then sure, you could apply your reinforced learning fairly easily. But for the reinforced learning and also multi-arm bandit, similar to the online learning, typically you don't have a notion of how good, how bad an algorithm is building. You don't have this average treatment in fact building, right? So this is a part is very different from the manual and the semi-manual optimization. So in summary, right, so automatic kind of optimization, there's a lot of good ideas around there, and you just want to optimize the objective function, right? And in some, online learning, easier way, multi-arm banding, reinforced learning, more complex way, but more or less you want to optimize the objective function. You don't necessarily care about the experiment. You don't have the idea to compare multiple alternatives in the experimental way. You don't really care about that. You still have a clear distinction between online and offline. So this is very similar to manual and semi-manual setting. And the barrier is non-trivial, right? So like I didn't mention in the detail, but for the reinforced learning, if you have the offline data set, then you want to apply to online setting, there's a there is a gap between your data and your online setting, then most likely your algorithm would fail, right? So like the policy you learn may not apply to online setting easily. So then there's some attempts that to address that as well. But in general, that's a very open question for automatic optimization. So very quickly, right? So we're kind of running out of time, but the last part well, I want to briefly mention about some idea around combining these two camps, right? So they all have pros and cons, and they are from different angles, right? So from manual, semi-manual optimization, they have deep roots in experiments, in statistics. They care about the average treatment effect, and use that as a central mechanism to determine how you want to improve your metrics, right? So that is one camp. The other camp is more from the machine learning perspective is I want to maximize, right? So I have a clear objective function. I want to maximize. I care about rewards. I care about the feature space and so on and so forth. I can do that. So can we do both, right? So this is one idea throwing out there. Can we maximize? Can we maximize the reward at the same time? Can say something about the AT, right? That would be great. Meaning, while I'm doing my maximization, I know how good, how bad I am doing with regard to some baseline, right? So not the oracle, but some other baseline, right? That would be great. So we did some early attempts last year publishing Wisdom, right? So this is really trying to combine these two worlds. And also we identified there are two costs of doing A/B tests, right? One is definitely the time cost, as I mentioned, how many weeks you would have in a year, right? So if each experiment need week, 2 weeks, 3 weeks to observe the difference, then you really bet on how many weeks you are going to use, right? Opportunity cost as well, right? So for instance, you launch an experiment, there has a potential money impact, right? So the control treatment is better than the control, but the folks in the user in control wouldn't enjoy, right, the benefit from the treatment for a while, because you have to observe that the difference, so it's statistically significant, and then you make a conclusion. So you know that you are making less money, right? So, but you have to wait, like the experiment to conclude. So how can you kind of tackle some of these costs, right? So in our work is really, we utilize a tool called Gershik test, and utilize that in a sequential kind of experiment test, domain, where you can actually make early statement, right? Make early statement of your experiment, and also probably dynamically allocating your treatment and control, and use multi-arm bandit as a vehicle, right, to do that. Now, in that case, you can actually tell, like, okay, treatment is better than control, and you are optimizing, right? You are not waiting there anymore. You are, you are keep optimizing. So this is a idea. So because of time, I won't go to the detail. You can check out the paper. But one thing I want to show that is we did some offline analysis, right? So, and then we can see that if we don't do anything, this is the timing. Whereas the vertical line is the time you stop the experiment, right? Because that's a fixed time you stop the experiment. Now, with the methodology we propose, you can stop much earlier and actually also detect the result that you would have waited, until the fixed time window, right? And so this is a really nice property, and also you would need much less data, so you don't have to wait 2 weeks. You have a much data kind of efficiency to make a statement. So this is a emerging topic, emerging area, right? So like I mentioned last year, there was a tutorial regarding the sequential experimentation, but the idea is really about how you combine, right? So how you combine experiments and optimization together, and you try to do both, right? And at the same time, you can derive some statement regarding the result. All right, so Moni, I think, sorry I was a little bit slow, but we finally reached the last section.
Okay, thank you. There are some questions, but I think we're just going to go through the concluding remarks, and then we should go reasonably fast. on this. So we're just going to spend just maybe 5 minutes talking about, what is the general method, challenge, opportunity, and so on, starting back with metrics. So what are the main takeaways? 3 levels of engagement: involvement, interaction, and contribution. We can define metrics for those, understanding the meaning of the metrics, how they relate also to the product application and so on. It is important to remember that contribution, the metric related to contribution, and contribution itself is a better predictor of high engagement. Of course, a lot of the work and the challenge is like how to make a user becoming a contributor. So this is really from understanding the engagement. Go back. You move too fast. The other thing that is super important, and a lot of the thing what Liangji discussed is really what happened after the click, and so on, is the value of the click. Not all the click are equal. There is the downstream engagement, whether it's in e-commerce, you click and then you're going, for example, to purchase, you're going to spend time reading news. In the context of playlisting, is organizing and so on. And often adding those help into actually predicting better engagement, which by itself predicts CTR better and so on. And this is a little bit, maybe the reinforcement learning and so on can help, because it's like those 2 steps and so on. Something that came again and again is understanding the relationship between intra-session and inter-session metrics. There is work that relate them. Maybe we can optimize them together. We can incorporate some of them, but really we're still at the level that we need to ensure that when we decide what to optimize or what to monitor with respect to the former, this also drives the business metric in the right direction. And often those business metrics come from, for example, the product owner. And here we focus on a big part of the engagement cycle. We should not forget that engagement is bigger. It's about the beginning of the engagement, but also disengagement. And for example, how to maybe be careful. Losing user is expensive. So how to ensure that we maybe predict churn and so on. Next, please. Opportunity. So there's a lot of work to do. That's why we're still so excited about this and so on. So for example, how can we come up with new metric? There's going to be new experience trying really to quantify user holistic feeling, and how can we just translate this? The usage of mixed methods is where you combine qualitative and quantitative method, but in particular the qualitative aspect to elicit hypothesis, which hopefully can inspire a metric development. And this is some of the work we have done at Spotify. Engagement is about satisfaction, is about experience wanting to repeat, but there's much more to it that is also important, is how do we consider, for example, non-engagement metric like diversity, discovery, a little bit revenue, and this was also already discussed also here when measuring user engagement. Something also that we didn't discuss is about, there's often going to be a lot of metrics. In the context of search, for example, there's massive, big dashboard, but also in other domains and so on. There's often what is called guardrail metric. We may want to move something, but we want to assure that other metrics are not moving in the wrong direction and so on. And it's again, the identification of those guardrail metrics. For example, when revenue is important, click-through rate may improve, but revenue decrease. This could be, we're not going to continue with this and so on. One more, please. And the challenge, bias. It's an important topic, how to account for bias when measuring and optimizing for given metric. It is well known in the rank list of results. That's a bias for the top results. There's a whole area around a bias in terms of the data sets and so on. So this is a different area, but it's also important to be aware. How to account for intent, segmentation, and diversity. Maybe we're trying to optimize, maybe we use a metric for everybody. Not everybody is the same. It's important to account also from why the user, who are the user, some aspect related to a segmentation. And something that I'm also passionate, but is hard, is how to incorporate negative signals. Is it the user, was it just one-off bad experience? Or is it something that, okay, we should not repeat this experience? There's often the notion of the mood in the moment and so on. And those that they're not solved. So yeah, it'd be good to have more work around that. Your turn.
All right. So for optimization side, right? So I think I mentioned through the way that there's a lot of work that emerging, right? And the nice thing about it right now is that we are seeing work from machine learning domain and from statistics, economics, and control theory, and more domains come together and study and borrow ideas and leverage different tools that are available and really, carry through. Right? So I think this also we also have a causal machine learning tutorial today sometime. I think this is a area I mentioned as a offline A/B testing and some of the combining two camps that where we could utilize those techniques. But overall, I think there are still open challenges in terms of offline online barriers, right? So I think there's a lot of attempts, right? So like establish correlations, understand the certain metrics, their causal relationship and so on and so forth. But in general, the offline online barriers are still there, meaning like the data drift, right? So, and also I mentioned when you want to apply reinforcement learning, there's item space issue. I think it's a very much a thing that we want to tackle. Also, like how do you optimize for a lot of different competing metrics, right? So I think I mentioned earlier in the multi-arm bandit and also reinforcement learning domain where the machinery is there, right? So, but you have to write down some heuristic combination of your metric. Okay, your objective function is 0.5 times your CTR plus 1.5 times your dwell time and so forth. Once you set up with that metric, then you can apply your nice reinforcement learning and multi-arm bandit mechanism. But how to come up with that trade-off, right? So I think that layer also is very much needed, and I don't think there's a standard or a very off-the-shelf way to tackle that. The last but not the least is the fate, right? So as Monia just mentioned, how can we optimize for fairness, accountability, transparency, and ethics are challenging, and sometimes in the past it was a afterthought or some, hey, let's say apply some post-processing, right? Let me apply some filter this here and there. But how can we really build in as a native component in the mechanism and algorithm? That part also is not super clear. I think we have a lot of good progress in case-by-case scenarios, but what is a overall mechanism and the framework, it's open to see. Last but not the least is, I think I mentioned this, right? So there's a lot of good momentum in the reinforcement learning setup. And I think the reinforcement learning has been very promising in a lot of AI domains. I would still call it a very early stage in terms of overall metrics optimization. I think there's a lot of good work have done there as well. But still, right, so I think the key challenge is how to scale to millions and billions of the user and the item space. And then sometimes they are highly dynamic. This is definitely challenging. And also, how do you mimic, right? How do you simulate the real world applications, right? So like a lot of the real world applications is far more complex than computer games or some other domains where it's more constrained and the rules and the ground truth is very well known. So a lot of real world scenarios are not like that. So how do you build simulators, right? So to simulate and make sure that your offline world can mimic online work and can utilize better data structure. That's probably also a very good topic to tackle. And also I mentioned the metrics as well. So with that, I think we are finally reaching the last slide, right? So this is really everything we have, and really appreciate your attendance today. And some of them is, especially for Monia, it's pretty late in the London, right? Already. What is the time now?
It's 8 p.m. It's just time for me for wine. I'm
Okay.
good.
Okay.
Yeah.
Okay. All right.
Yeah. So we have some questions, and it will be good to have those questions put in the VFairs because they stay live. We have, I believe, to give up the Zoom link because it's going to be used for the next session and so on. So we have question about using retention metric into ranking. We have aspect related to the banding algorithm. I have no idea how to save those questions for us to respond.
Yeah. Could you folks please ask those questions again? Probably this is a little bit duplicated, but in the WeFair, right? So that in that way, Monia and I could check out later in terms of where the questions goes, but we can answer those things in the chat probably, but this Zoom link will expire, right? So Zoom link will expire very soon. So please probably ask there as well.
Yeah, and any feedback in terms of the content, what we should maybe in the next version add more of, add less of. Yes, the recording is going to be available. It's going to end up somewhere, I don't know where, but it's going to end up. So please do, if you go on the virtual system, VFairs, you can access the actual tutorial, and then we can just continue sharing and so on.
Yeah, and it's a mutual learning experience, right? So at least for me, is I learned from VDAT that the utility framework is definitely something I want to check out. So thank you for sharing multiple times. I think this is very relevant work. And this is a good way to discover relative work and nice things.
Yeah, this is also adding, there's so much work. I feel that search is really advanced in terms of many components. So it will be good actually to revisit, to have more respect to search, because there was a lot of discussion about this, or learning to rank and so on. Okay.
All right, I think we could stop here and take care of everybody and enjoy the other sessions.
Okay.
Thank you.
Okay.
Bye.
Thank you. Bye-bye.